Okay, the Unilag anthem. Thank you. We may be seated. So on this note, I would like to invite to the I table our dear Dean of Science in person of Professor Ayejulo. A round of applause. They made you say. Joining him is our amiable acting head of department of computer science that we also transitioned into a faculty of computing in the person of Dr. C.O. Yinka Banjo. Yes. I also have the honor of inviting our distinguished guest and facilitator from Europe, all the way from Europe, to impart the gospel of green software engineering to us here, starting with, in no particular order, Dr. Bijet Pasef-Slaver. A round of applause. Next, I call on Dr. Collins Venters. Okay, so, well, our amiable Dr. Shola Oyedeji too from the Lund University, Finland. You're welcome. You want to, okay. Oh, good, very good. Now, I haven't called on the guest. So I would like to call on the HOD to give a welcome address. HOD, ma? Do you want to do it there? Yes.
Okay. Okay, thank you so much, Dr. Rufai, for this program. I want to welcome everyone. My job here is to welcome us for the program. So I'm not going to take much of your time. I just want to say one thing. We welcome you the next round of program in University of Lagos, and we are so grateful that you're here again. And Dr. Rufai just mentioned that you're here for spreading the gospel of green and sustainable software engineering. And that is appreciated because our department, computer science, has transitioned into Faculty of Computing and Informatics, and software engineering is one of the departments and a course that people will apply for and graduate with. So we want to welcome you that this is timely, and we are here to receive the gospel. And I hope this can also translate into you helping us when we're building the faculty also, because the faculty will have 3 departments. And if you also can help in blended teaching and learning on software engineering and all the new trends of software engineering, that would be very appreciated. You're welcome. I want to welcome everyone. And I say relax and enjoy and learn. And I'm here also to learn. Thank you very much.
Thank you, Ma. So next, I would like to call on our Amibu Dean, Dean of the Faculty of Science, in the person of Professor Ayejuyo. Professor.
I say good morning to each and every one of us on this special occasion. I'm so excited to be here and to represent my dean, who is unavoidably absent, Professor Olayinka Ashekun. As my head of department have said, I believe most sincerely that we are here in for an exciting time. We have put together the aspect, galaxy of stars from all walks of life. And it is gratifying to know that the participants are eagerly waiting to hear from you. Just as the head of department has said, it is a crucial moment in the annal of the faculty where we're going to be split into 3. And Faculty of Computing is one that stands out, that if you knock at the door anytime, you will always find them there. They are so unique. While others are still fighting here and there, they are unique. And we know for sure that everybody is waiting to see how that particular faculty will thrive in a few years' time. Because ordinarily, that is where the world is going. IT, AI, everywhere. Though, as a chemist, we believe that we rule the world. Here, you will come around to assist us in doing the greater things. And on behalf of everybody, I want to especially welcome Bridget. You're most welcome. First, you're welcome. Oyedele, you are welcome. Thank you so much, head of department and all the participants. This is a university of first choice. And I know that by the time you move around, apart from the lectures and the training, you will enjoy the aura that the university will offer. Once again, I welcome you and say, have a productive training. Thank you so much.
Thank you very much, sir. Another round of applause for our dean. And what in this world isn't chemistry? There's nothing in this world that is not chemistry. Polymers, all what we are sitting on, chemistry. Yeah. In collaboration with computing, yes. In computing. Exactly. Thank you very much. So next, we take on is a tradition anyway. We take citations for our knowledge imparters, okay, like our professors, our facilitators. So on this note, starting in no particular order again, I'd like to call on one moment. Okay. Dr. Bridget Parsons Slider. of the University of Gothenburg, Sweden. May you rise for your citation. Thank you very much. Dr. Person Slider is an associate professor at Chalmers University of Gothenburg, an adjunct professor at LUT University in Finland. She explores sustainability, resilience, and well-being in software engineering. She is a founding member of the Karlskrona Alliance and a co-author of the Karlskrona Manifesto, which happens to be a software engineering methodology. Our interdisciplinary work bridges technology, mindfulness, and permaculture, as highlighted in our 2022 TEDx talk. A round of applause for Dr. Passenspire. Thank you. Next, I call on Dr. Collins Venter of the University of Limerick, Ireland. He's an associate professor at the University of Limerick and a research software engineer, is a research software engineering as CERN associated with the Atlas experiment. That's the largest multi-general purpose particle detector experiment at the Large Hadron Collider, that's LHC. Dr. Venter research interest focuses on sustainable software engineering from a software architecture perspective, from pre-system and post-system maintenance and evolution. A round of applause for Dr. Venter. Thank you. Next, I call on Dr. Shola Oyedeji. He's a postdoctoral researcher at Lund University, Finland. Dr. Oyedeji's research work centers on integrating sustainability dimensions. That's the human, societal, environmental, technical, and economic into software design. As a member of the Sustainability Alliance, he promotes sustainability practices among software professionals and leads educational and research collaborations between Europe and Africa. A round of applause for Dr. Oyedeji. And he happens to be the facilitator of this collaboration. Thank you very much. Next, we'll move on to what we have on the program. Can you project the program? Technical unit. It's projected already. So, okay. The Afritech, we have other dignitaries, but I mean, along the line, they will still come, like Professor Ibrahim Ismail, that's the Director of International Partnership, and is the Afritech UNILAG Coordinator, okay? And the Vice Chancellor too, from what he said, will come later, maybe it's the three or thereabouts. So that is, so on, after that, then we move on to, photo session. Let's go for a photo session, take photographs. Then we now come back for the keynote. Outside? Or is it okay inside here? Okay. Chris, let's Thank you very much for the photo shoot. At least we were able to exercise ourselves. So the next item here is the opening keynote to be presented by Associate Professor Bridget Pazen-Slider. The topic is sustainability in software engineering, from global goals to code commitments. Prof. Like to use it.
Yes, please. It's up to get the link.
That's not what you want.
I have the link, but because it was in the Africa group chat, right?
Yeah. Yeah. Is there a possibility to plug this? That was my, I don't think that's have a strong angle.
Well, to register first. Pardon me, I have to register for our event to be allowed into the Zoom. Well, yeah, I mean, I have 26%. We'll see how far it lasts.
Hopefully.
to start the video or will you use this video? Do you want me to start my video as well, or will I just be on that video? Okay. Yes. Mhm. Yes, that one's good. Thank you. Mhm. Wonderful. Can I get a check on the audio? Can the online audience hear me well?
Yes.
Yes,
Okay.
we can.
Hear you.
Thank you
Yes.
so much. So we have an echo going on here. I don't know if we can lower that at all. It seems to have faded away, maybe. Good. Let's give it a try. So, good morning, everyone. Thank you so much for welcoming me here. I'm very excited to have you, and I'm especially excited to see how incredibly successful the University of Lagos has been at recruiting their students earlier and earlier. You're most junior student here in the room. I'm very impressed. And I am very happy to be back here in Nigeria. This is going to be an interactive keynote. So that means you get to pull out your phones because I am very curious also to know who we have in the room here. Now, Colin, I'm not sure why it's not showing the QR code as that it was supposed to. Have I logged in? I have never logged out. I'm still on the same Wi-Fi, yes. Let's try this again. Let's see. It turns out it cannot do the presenter view. Okay, we learned something again. So now I'm going to minimize this window, and now you can use your phones on this lovely QR code because we are very curious who our audience is this morning and also online, because I can guess for some of the people in the room, but I have no idea for everybody watching online, and we would love for you to be a very active part of this. So please scan the QR code, and then we will see the roles coming up here as you answer the poll. Good, we have a first answer. The undergrads, they're quick. Wonderful, we have some industry, we have some faculty, undergrad students. Let's see, any PhD students in the call? We have a lot of other. I am slightly curious who the other are, and also we couldn't figure out how to put a text field to say, please explain your other. I think so too. Good, good. Where do I see the number of answers in this? Okay, up there, 12 answers so far. 12 answers, 64 people in the call and 10 more in the room. Masters maybe, yes, that may well be the case. More faculty. Well, we do have the option of faculty, so I hope we would select that. Okay, we're getting a very clear sense that the presenter has not provided enough options for this poll to be the most useful. We'll give it one more minute. Oh, the link is not working. Shola, Colin, are you in the chat? Could you post that link and kindly monitor the chat a bit for me? That would be lovely. Thank you. Okay, maybe we'll leave it at that. We have a very first impression and a party in the courtyard. Let's carry on. So the next one will also be requesting a little bit of input from you for me to better understand where we're coming from, to better understand what your perception of sustainability is before we start into the contents of this talk. So I would love to hear what motivated you to come. We want to make sure that we we want to make sure that we understand what brought you here. And then there'll also be a question on the next slide that will ask you, well, what do you hope to get out of it this week? So we would love to get a little bit of your motivation of why you chose to attend. Upskill, learn more about green computing, good. Learn about building sustainable solutions for the African tech space, yes. So it's very good that we have plenty of facilitators for the summer school, because about the African tech space, I'm the one who's learning. That part you can teach me about. I can teach a little bit about building sustainable solutions. Gain knowledge on green software engineering, good. Understand what green computing is about. Okay, first I'm hearing about it. Well, welcome. Broaden my knowledge on green software engineering, good. Network and connect with great minds. And I want to build a career in software engineering, very nice. I was informed by my head of department, very nice. Note, it does not say my head of department made me come. It was still voluntary. I'm happy that you chose to come. Upskill and give back to the community. That's great. Learning about building sustainable solutions in Africa. And achieve more knowledge in AI. Okay, yeah, I'm sure we'll touch upon that at some point this week. I mentioned it in this particular talk as well. Knowing more about the program. Okay. Knowledge acquisition. Mhm. Green computing. Desire for deeper knowledge and keeping pace with technological advancements. Mhm. Okay. So we get a first sense of what brought you here. Now, as an instructor, I would love to also understand what you expect from me as I came here. Okay, getting to know trends and upskill knowledge. Good. So for those of you who already put in an answer, think about what are my expectations for this week? I'm just going to wait a couple more moments to let people submit their answers. Mhm. Good. And we see the clusters up here on top. So there's software engineering, there's gaining knowledge, learning about sustainability, green computing. Mhm. Good. Let's move on to your expectations. At the end of the week, what does it look like if you have the sense this was a week well spent? This was really worth my time. What are your expectations for us this week? Green AI. Good pick. A thought leader in the African tech sector. Wow, that's a great aspiration. I like it. Knowledge in building green solutions. I wish to gain more knowledge about the software development cycle and get advice and best practices in software production from industry experts. Wonderful. Yes, we will also have industry experts on stage. How green energy can impact my environment positively. Knowledge about the program. Opportunities in green software engineering. Yes. Good. Understand sustainability in software development better. As to make the world a better place. Yes. We all can contribute in our ways. Acquire practical knowledge. Green solutions. Sustainability education. Yes, that's also very important. Implement an idea, use feedback, best practices. Solve complex problem in future cohorts. Yes. Different areas of research. Yes, we will also touch upon a lot of them. And we have some of the clustering at the top. So there is a lot around green, knowledge, sustainability, and again, software engineering and best practices. And then some environmental elements. Oh, now we move to the next slide. I don't know who that is, but welcome. Green STEM. Okay. Beautiful. Thank you for sharing your expectations. And I'm fairly confident that we can touch upon all of these. Okay, I hope that gave everybody enough time to put in their answers. If you miss a slot, always feel free to share an answer with us in the Zoom chat as well. We'll keep monitoring that. So, why this summer school? Why do we think this matters? I found a YouTube clip narrated by Julia Roberts, and I don't know if this is gonna work. Yes, it looks like it is. It's a short 2-minute video, so bear with me. Ah, I did not share my sound. Now you hear it without the sound. I will read it out. I've been here for over 4.5 billion years. Just imagine I have the voice of Julia Roberts. That is 22,000 times longer than you. I don't really need people. I'm Earth, but people need me. Yes, your future depends on me. When I thrive, you thrive. When I falter, you falter. Or worse. I've been here for eons. I've fed species greater than you, and I've starved species greater than you. My oceans, my soil, my flowing streams, my forests, they all can take you or leave you. How you choose to live each day, whether you regard or disregard me, it doesn't really matter to me. One way or the other. Your actions will determine your fate, not mine. I am nature. I will go on. I'm prepared to evolve. Are you? So the video makes the point that we're not going to save the planet because the planet does not need saving. What it does need is us humans to behave so we can keep a space on this planet. And if we don't give the planet a voice in how we develop things, then it might just shake us off the planet. And yes, I've been called a tree hugger plenty of times in my life, and there's probably some truth to that. And the video is right in that the planet doesn't necessarily need us. We do need the planet so we can stay here and live. Now, before I dive into how I think about sustainability, I would love to hear from you how you understand sustainability. And I promise I will give you more input. We're not going to keep throwing questions at you the entire talk. That's not the point. But I need a little bit of input from you at the beginning so we know where we're starting from. So at the end of the week, you will know whether something has really changed in your understanding and in your knowledge in this area. So how do you understand sustainability? Sustaining ourselves in our environment. Durability, yes. Having something that is long lasting. So that's the direct definition of the word. It means to maintain something over a long period of time. So have things long lasting. Preservation, yes, that also. Safe and not depleted. Durable. The ability to keep things running, yes. Not detrimental to society. Yes. Longevity. Mm-hmm. Using things over and over again. Yes, reuse is an important part of it. Good thought. Ability to rejuvenate. Mm-hmm. Continuous use of resources without depletion. Mm-hmm. Properly using something. Wait, where did that go? Energy efficiency. Yes. Continuous usage. Okay. Now we're only getting the most important keywords of the answers since they're becoming more. Eco-friendly hosting. Yes, good thought. With all the cloud computing that we do these days, continuity. Being responsible with our resources. Safeguarding. More continuity. Let's see if we can get a 20th. Green coding practices. Yep. Seed. Okay, it seems we have saturated this somewhat. Things are being upvoted. That's good. Then I have one more thing to do for you, and this time you only have to vote. So we would like to see which dimension you rate most important. Is it the environmental dimension, which means protecting natural resources, air, water, land, and ecosystems? Is it the economic one, ensuring that systems deliver lasting value while maintaining capital and cost efficiency? Is it the technical dimension, designing for the durability and adaptability of software, infrastructure, and data in changing contexts? Is it the social dimension, which means fostering community cohesion and trust and equitable access to digital services? Or is it the individual dimension that supports personal growth, dignity, health, and access to education and essential services? Okay, environmental seems to be strongly leading. And there is no truly right or wrong answer to this question. My personal preference is also the environmental one because all the other dimensions kind of go out the window if we don't have the environmental foundation. So that's my reason for why I think it's the most important one. And other answers might also be viable. It's a personal priority. Good. We also have one vote for the individual one. Two for the individual one. Nice. Okay, so it seems we continue to have a strong focus on the environmental and then some votes on the other ones. And now we will get to the part where I give you a lot of input. If you have questions, you're welcome to put them in the chat and we will collect them so that people online have the same chance to put in a question as the people here in the room. And then we will have a prioritized collection at the end. Good. Okay, so we have some more votes for the others as well now. Technical. Okay, thank you. Thank you for sharing your thoughts on this. Now, we have known since the 1970s that, well, we've known before that we live on a finite planet, but in the 1970s, there was this book that was published called Limits to Growth. Anybody familiar with the book? Have you heard of the title before? Okay, so my hand raising, which I like to do a lot during talks, now kind of falls because I don't see all the people online. It is a book that says, you know what? We have limited resources on this planet, as shown by this red curve, which means if we continue to overuse too many resources per person, eventually our resources will run out. And that means after a while, our population also has to decrease. Now, they have made the prognosis starting in the early 1900s, going up here, and they wrote the book published it in 1972. And one could be very curious, especially if you're into statistics, how well did they project it? And it turns out they did really well. So if you look at the dotted lines, that is the prognosis of the book. And if you look at these strong lines, they are the observed trends and measured trends in between the years 1970 to 2000. So they have been very spot on and accurate with their predictions. Now, what does that tell us? Well, we still live on that finite planet, and apparently we have not done enough about this. We have started doing things about it. There were the United Nations Sustainable Development Goals that were developed in 2000. And in this illustration, you see how they can be distributed across the biosphere, the environmental dimension, then the societal dimension, and then the economy. And up on the very top, you see world peace. And it shows this foundation of the environment is really important to enable any of the other ones. Now, the goals are very abstract. They say, let's end extreme poverty. Goal number 1 here. Let's make sure we protect life on land. Let's make sure we keep our water clean enough and give everybody access to enough food and to education. But what does that look like? How do I know whether we've improved anything? That's what we have the targets for. So we define the SDG targets as something like significantly reduce marine pollution, make sure we maintain coastal ecosystems so that life below water can be okay. Now, 25 years into the Sustainable Development Goals, how are we doing? We are not doing so great as of now. On this circle, on this radar chart, you see how much the targets have been reached by 2030. In 5 years, we should be reaching this dotted line here on the outside. And it seems that for half of the targets, we're very far away. Not only are we very far away for some of the targets, we are even reversing for some of the targets. So here you see the SDGs all lined up again. And protecting life on land, we're going the opposite direction. We have actually made it worse by now than compared to 2000. This is getting dark. There was another researcher, or actually a very large group of researchers, that established in the early 2000s a concept called planetary boundaries. And the planetary boundaries are the conditions to keep Earth a safe operating space. That means if we have not enough fresh water, or if we deplete the ozone layer too much, or if we put too much biogeochemicals into the ground, we're going to be in trouble. And we have successfully done a lot of that. So where there is green, up to green, we are within the planetary boundaries. And then we get into the really risky area, and you see that we have surpassed by now 6 of the 9 planetary boundaries. That means we have very successfully in quotation marks, made our operating system, planet Earth, very unstable, our ecosystem. And we're not sure yet where that is going. But Birgit, it's not all that bad, right? We have done some things on the positive side, and we want to maintain a good foundation within those planetary boundaries, right? Yeah. So there was this researcher, her name is Kate Raworth, who said, we need an idea of how to thrive as a community, as a global community of people within this framework of the planetary boundaries. So on the outsides of this model, you see the planetary boundaries that says, we want to make sure that we don't make our oceans too acidic. We want to make sure we keep climate change at bay. We want to make sure we don't lose too much biodiversity. But on the inside, we also want to make sure that everybody has enough clean water, food, health and health services, education, that everybody has an income and work, that there is social equity, gender equity, that there is housing networks and energy for all people. And this model is called the donut model, because if you just look at the green part, it kind of looks like a donut. So if you're very interested in what the economic and social boundaries in combination with the ecological boundaries can look like, then I recommend reading this book that I have linked down here at the bottom, and we will make these slides available to everybody who's participating. One step beyond this donut model is to say we really have to degrow. And this was an approach done in systems thinking, where the researchers said, if we think about the Earth's biosphere in terms of incoming solar energy and the natural resources, and then our economic system as something that produces outputs, we see that we mainly get somehow degraded materials and degraded energy out there. And where are the humans in this picture? Well, the humans are the low-grade thermal energy, because if I put food inside my body continues to live, and it produces a little bit of heat and some other things. So if we say, now that we know that we're overshooting most of the Earth's resources, what can we do against it? Well, use less of them, produce less waste. And then there is these principles of degrowth that are helping with that. And we had in some of your answers already, we need to reuse things again and again. That's the principle of circularity. We need more sharing and cooperation in between people. And we need local production so we don't have to ship things all around the planet where we can avoid it. But the most important principle of degrowth is to change the incentive from let's earn more money and grow the economy to let's make sure that we all can live a good life, because that's really what we're after. We want to be able to take care of our families and to enjoy life. If you're interested in this concept, I can recommend the book Less is More by Jason Hickel. That goes into a lot more detail here. Now, we are in the tech space, right? This is about software engineering. So let's look into the first person who started doing research in this area, and that was Lawrence Hilty. He already started in 1990. That was when I was in primary school. And he has been doing research about what it means to look at sustainability from the computing field. And he says it's always a part of the solution as well as a part of the problem. So in terms of a part of the solution, it's very good at making more from less. We can have optimization effects and substitution effects. So for example, a lot of people didn't have to travel here today from all over Africa because we're doing this as a hybrid event. So many people can join online. And over time, we see deep structural changes towards a more dematerialized economy. We didn't print out a stack of scripts for you to read through. I'm presenting a slide set and we will share the electronic version with you. But there's also the part of the problem, which is we produce a lot of these devices and they don't last forever because we haven't figured out how to manufacture them so well and maintain them so well that they don't degrade. We also often have these induction effects. If I buy a new piece of equipment, it might require new accessories as well, and it requires constant updates. And finally, we have the rebound effects. And that means I made something so efficient that now I start using more of it. The rebound effect is explained in a bit more detail on the next slide. So the rebound effect was discovered in the 1870s, way before the field of computing was born. And in the 1870s, this gentleman, William Jevons, was looking into the question of coal. And he saw, we have learned now in the UK to burn coal way more efficiently, so we can create more heat to warm houses with less coal. However, they observed that instead of now using less coal, England was starting to use more coal. And why was that? Because the efficiency made them sell the thermal energy more cheaply, and that means people just got way more liberal about heating their houses. Now, here we are in a warm country, so here it's maybe the other way around. If we manage to make ACs more energy efficient, then maybe now every person says, oh, now I can afford 2 ACs in my house because they use less energy. So in the end, we didn't save any energy. We just made it more economic and more affordable. And we see that in the same way all across technology with the cars, especially in Europe. I don't know how much it is here yet, but in Europe, we have a ton of electric cars now driving around. And people say, oh, this car is so energy efficient. Now I drive everywhere. We have the same thing with computer miniaturization. The computing power of this device used to run a whole company a couple of decades ago. Now it's just my device. So we see that while efficiency is a good thing to strive for, it can easily backfire. And it's illustrated in this comic here. These new cars are so efficient, everyone is driving them everywhere these days. And then we have a huge traffic jam, which doesn't serve anybody. Birgit, somewhere in the slide set there has to be the good news, right? Let's see. We're not quite there yet. Let's first look at our emissions globally. So our CO2 emissions over time, despite all this energy efficiency stuff of the last 20, 30 years, has been still increasing tremendously. And here it looks like China are absolutely the bad guys. They have by far the most emissions. They're also one of the largest populations. But if we change it to a per head emission per country, then it looks a bit different. Then there is countries who definitely spend more energy per person than China. China has a large population, which we see by how wide this block is. And in the US, in Russia, in Australia, New Zealand, Canada, Saudi Arabia, and the Middle East, people are definitely spending way more energy per person. However, this big China block, where does that also come in? We rely on China a lot for manufactured goods. So if I look at the bottom of very many household items that I own, or also items at work in the office, it says made in China. Not on the bottom of this microphone, but we do have plenty of devices of that kind. I'm sure if we look around in this room, we'll find a few. So we do rely on China, and hence that means all of us are also contributing to the emissions that China is producing there. To rectify this slide a bit, but haven't we had a lot of work in computing that has been making things better? Yeah, there's all this green computing stuff. There is energy efficiency, there is renewable energy integration, there is sustainable software development, there is e-waste reduction, cloud computing, and virtualization. All of these are good things. So we have done some parts here, and then there's rebound effects. But if we look over here, we often quote the number, oh, information technology is responsible for 3 or 4% of global emissions. It's not that bad. Well, if we look into 16% transport, 7% buildings, 28% electricity, 18% agriculture and land use, and 30% industry, all of these sectors use a tremendous amount of IT and software solutions, which means that we as software engineers are in the unique position of making a very big difference in all of these domains by the solutions that we provide. This is called the handprint of energy, the handprint of software, as opposed to the footprint. The footprint would be what it directly consumes. Like as I plug in this computer and use an application, it uses certain energy. And if I use this application to then stir some other mechanisms, that is the handprint. If that makes things better, that is a good handprint. There's also a lot of greenwashing in the IT domain. So these days we've seen a lot of advertisements like, we have set a goal to achieve net zero emissions across all of our operations and value chain by 2030. Okay, there is a footnote. The researcher in me gets curious every time I see a footnote with a slogan like that. And it says in the footnote, we aim to reduce 50% of our combined scope 1, 2, and 3 by 2030. And for the other 50%, we plan to invest in nature-based carbon removal solutions. What does that mean translated to everyday words? It means I will continue to blast emissions up in the air, and I will pay you, for example, to plant a forest to offset the rest of the emissions. In my head, that doesn't make my emissions go away. But in front of the economy, in front of taxes, it seems to do that. We call that carbon taxes or carbon trading. So that's a lot of what is going on in the big IT industry. And in this case, it's Google. There's also plenty of other big companies who do the same thing. So good that they want to reduce 50%. It's a bit of greenwashing that they say, and for the other 50%, we just pay somebody else to plant a forest or something like that. So I want to point that out. If you come across that in the future, promises like that, look into the fine print. And we've seen greenwashing on the rise a lot over the past 10 years. What I find really interesting, in the last 5 years, sustainable brands have risen by 400%. And the real trouble is all these little things that they improve and claim to improve. It's good that they do these improvements, but it takes attention away from the real environmental threats. But we can still solve it by technology, right? Maybe. Maybe. There's also a lot of criticism that points to techno-solutionism, which is the belief that we can solve everything by technology. And one of our friends and colleagues, Christoph Becker, has published this book called Insolvent in 2023 that is available completely online for free by MIT Press, where he describes how computational thinking has helped us very much by teaching us how to decompose a problem, how to recognize patterns in a problem so we don't reinvent the same things over and over again, how to abstract from the details so we can reuse solutions, and then how to design algorithms to help us. All of that is good. We have learned how to engineer great solutions. This engineering sometimes falls a bit short in terms of it doesn't see most of the context of what is going on in the world around it. So we see the events of what happens in the world, but in computing, we don't have a very deep discipline of inquiring about why a behavior pattern occurs or why the structure of the system is a certain way. And often that lies in the mental models. And then we end up with things like systems that exclude part of the people that they were made for, because the developers were in their own minds and in their own experience, and they didn't think about that particular user group. And then it happens to be not a good solution for those users. Birgit, is AI going to save us? I heard AI is pretty powerful. So what about AI? Over the last couple of years, we've had the tendency to incorporate AI into everything. If AI could cook my coffee, it probably would be in my coffee machine. The trouble is, it is very resource intensive, and people don't think about that very much. So that means by including it into everything that we do, we are spending a lot of environmental resources, for example, water, because the big server farms that they use need a lot of water cooling to deal with the heat that the systems produce. And so Christoph Becker, the same gentleman who wrote the book on the slide before, made a campaign that's called Water or AI, where he puts stickers on the computers, and you can see one of those stickers on the back of my computer for the people who are in the room, that points to the fact, hey, we're using too much water because we're using too much AI when it's not really needed. Another effect is that we've seen a lot of air pollution come from these large centers that help with all the computing, and that is creating health tolls. There were also a couple of other challenges we've had with both social media and now AI. So the Center for Humane Technology, which is composed by mostly former members of some of the big 5 technology companies that said, we don't want to subscribe to their way of working anymore. A few years ago, they gave this talk called The Social Dilemma. Actually, there was a whole documentary on it. Has anybody seen The Social Dilemma or heard of it? No. Okay. So they were explaining how social media is designed to get us addicted. Has anybody of you ever spent a little too much time on Facebook or Instagram or YouTube, and then an hour later you're like, oh, wait a second, what just happened and why am I still on my phone? It has happened to me in the past for sure. Can anybody relate? Thank you. Okay. So we've created all these troubles with social media and we haven't solved any of them. However, now we make it exponentially more powerful by integrating AI into everything, which means we still have those same challenges. It's just worse now because we're releasing AI capabilities everywhere as fast as possible. The same Center for Humane Technology also brought out a framework that tries to help with this. It is a framework that helps us judge, is this technology that we're thinking about designing or putting out there right now actually going to serve humanity well? And it looks at things like which values it centers, whether it respects human nature, and that means, does it exploit some psychological mechanisms or does it actually really help? Does it build a shared understanding in between people or does it try to spread misinformation? So this framework I find really helpful when we talk about socio-technical systems. There's also ISO standards because, you know, I'm German, so we like our standards and we like our laws. So I had to take a quick look. What standards and laws do we have to support us in the sustainability effort? And in the ISO standards, we see the 14,000 family on environmental management and the 26,000 family on corporate social responsibility. But there's also laws. What rights does Mother Nature or the earth have in legislation? In Ecuador, it's actually written into the constitution. It was proposed already in the 1970s. It finally came through in 2008. Ecuador was the first to grant nature constitutional rights. And since then, nature has been given rights in several fights against roading of forests, where companies wanted to plant more soy or more oil. It hasn't solved every single challenge, but it's a starting point. And similar in New Zealand, where the Maori culture has a very strongly ingrained connection to nature. If we come back to software engineering, nature is a key stakeholder here. Nature provides us with ecosystem services. It provides us with all the energy, it provides us with food, it provides us with national or continental defenses by putting oceans in the middle. It has climate regulation, it has some erosion control, naturally built in, and it also has cultural services. And then there's risks associated that we get to manage for nature as a key stakeholder. And that's all the troubles that we have essentially created. Man-made environmental disasters, migration because of climate change, extreme weather events, all of that. So nature is a key stakeholder in software engineering, and we have to account for that. So now we get to the part where we look briefly at a couple of the works that we as a group have done. And one of the first ones of those was the sustainability goal reference model. And up here, you see the 5 dimensions of sustainability that I had in the poll earlier: economic, technical, environmental, human, and social. And we break those down into what values do they incorporate and what are the activities that we can support with. I'm going to go over a number of approaches without explaining them in a lot of depth. So this is kind of to provide you an overview. And if you say, this one is particularly interesting, take a note of it and ask me about it later. We can go into more detail on any of them, but this is the overview talk for the entire week. You will always find the reference on the side, and for the later ones, I also have QR codes embedded in the slides where you see the PDF versions. So yes, here are the 5 dimensions. And then I've also made a stakeholder reference model for sustainability, where we find all the different people that could help us represent sustainability. And on the right-hand side, you find a description of the roles and how they relate to sustainability. I know this is a bit too tiny to read on the slide, but you will be able to read it in the PDF. It's not for reading right now anyways. Based on that, in 2014, I developed an artifact model that would help us during the early phases of software engineering to integrate sustainability. And this week, we'll also be speaking about how we can take a model like this and integrate it into a software engineering course, where we speak about the sustainability stakeholders, what a sustainable business model could look like, the related objectives, and then the system vision that we can derive from that. And down here, you see this little icon called sustainability analysis. We're going to dive a little bit deeper into that, because in fall 2014, we sat together and we wrote a manifesto that was talking about the misconceptions about sustainability, that it is something that we can solve with technology or that we can do immediately, and that there is a tendency to discount the future. And then we said, maybe instead we need to focus on the interdisciplinarity of it. Maybe we need to focus on the long range impacts. And maybe as software engineers, we can do a lot better in this area. And then we had people sign off on this manifesto. And there was about 500 people who signed this manifesto. And then a lot of them came back around and said, so you wrote this manifesto, Colin, Birgit, Christoph, a few others. So what do we do now? What if I agree with the things that are written in this manifesto? What do we do? And so we went back to the drawing board and developed the Sustainability Awareness Framework. This is the lovely group of our colleagues that was involved in that. And this framework takes the 5 dimensions and has questions for each of the dimensions that would then help find out what are the long-term impacts of a software system that we're developing right now. So here you see a small version of it, and the QR code, which I'll repeat in 2 slides, leads you to the workbook where you can try this out. So first, we're going to zoom in on one of those diagrams. This was an example we did a few years ago in class for Twitter. By now it has a different name. And we collected with our students all the impacts that they could think of in these different dimensions, and we linked them to each other. And you see, we came up with a lot of impacts in just about 20 minutes of brainstorming with master students. Please note, those are potential impacts. So within this brainstorming, we can only say, this is a thing we should probably think about. And then we need to do the homework afterwards and follow up with the assessment of how likely these impacts are and how much damage they really create. And you see the paper on the right where we describe this in a bit more detail. Now, if we take this framework and put it in the wild, if we try it out with participants, this was a screenshot where we did it online with about 100 participants during the pandemic. Then we developed this workbook version of it that would guide people through the process by themselves, so that not one of us would have to moderate the event, but people can go through the guidance by themselves. And here's me presenting one of the related papers at a conference. So that QR code will take you directly to the Zenodo publication of this workbook. And we've tried this out with a number of companies, with a number of industry partners that you see on the bottom, and with a number of universities that you see on the top of the slide. So it seems to be working well for enough people to give it a try. Now, another concept that I would like to point out for a brief moment is leverage points. Leverage points were promoted by one of the people who was involved in this 1970 Limits to Growth book. So in this very original reference, they already pointed out there is things that we can change in systems that are easier to get to, like some of the parameters that we use, for example, the price that we charge for something, or the opening hours when a service is accessible. And there are things that are harder to change in a system. For example, the structure of the system. It's very difficult to change the structure of a university because it's a very big institution that has been run for a long time and that many people are involved in. So if we try to change the structures here, it usually takes quite a while and takes quite some effort, but the effects might be really big. I've taken that concept of leverage points in 2018 and applied it to software engineering. And in this article, I explain how we can use these ideas a lot in software engineering. So again, we're not going to go into this in detail right now. I would like to plant the idea with you. And if you ever come across it and be like systems thinking, I wonder, please read that article and see if you find it helpful. This week, we're going to talk a lot about sustainability education. And when we look at the different sustainability competencies, there was an interest in our group to say, what does industry think about this? Because we don't only educate for research, we educate a lot of people who go into industry and maybe don't do research. So we talked to, if I remember correctly, about 15 companies and did interviews with them and a couple of focus groups, and then looked into what they thought was most important here. And the reason why they were interested in sustainability was primarily for business and then also for their customers and stakeholders. So it is very strongly focused on their, well, major economic interests. And this also is mirrored in the difficulties that they have encountered. There's a very big majority that said we have trouble arguing financially for some of the things that we would like to change because the additional costs, where do they come from? Or where do we get the money for those additional costs? But then also the understanding. So we really need to understand what we can actually do better here. So that was the industry perspective. And then we also wanted to understand, well, what about sustainability education in computing as of now? Who does that outside of us 10 people? I'm going to skip this one. So we did a big literature review in computing education. And we found that there is quite a bit of computing specific topics and also some sustainability specific topics, and a bit more on educational organizations in general. We found a number of learning objectives across all of those columns. One is, let's get some really topic specific competencies. For example, sustainability driven design, which is one of the goals of this week. Then there's cross-cutting competencies like systems thinking. There's gaining awareness. So sometimes the awareness for sustainability is still lacking. And there's gaining practical experience. You can also find this article by following the QR code above here. Where do we go from here? Based on these two articles, last year, I spent a lot of time thinking about these sustainability competencies, thinking about values, thinking about the future, thinking about a long-term strategy, applying systems thinking, which means being aware of how my actions affect the rest of the world and what dynamics are happening, and the implementation thinking and how do I come to a solution for this. How can I take those 5 and embed them into the research design process? How can I take those 5 and make sure that the research that I do, that I aspire to do, aligns well with sustainability goals? And I've developed a short set of guiding questions for that. So if you're about to start into a thesis project, a master's thesis, a bachelor thesis if you do them, or a PhD thesis, then you can use these questions to help structure your future research and to get to good research questions. And this chapter was just published 2 weeks ago in the handbook on teaching empirical software engineering. And you get directly to the chapter, to a PDF of the chapter if you follow this QR code. I'm also repeating the QR code on the next slide. The other piece that this chapter gives you is a research canvas where you can break down what your sustainability research could look like. It will let you take notes on the research strategy, on the resources that you need, on the values that you wish to apply, and then give some space for intentions and reflections. Give you another couple of seconds to scan that code if you wish. Okay. And finally, the chapter also explains the impact on the different levels of leverage points. We're not going deeper into that right now. Instead, the last couple of slides that I have here are how do we put this all together for sustainability education and for making our courses a bit more sustainable? We've thought about it in Gothenburg at the university where I come from. We thought about many, many courses and how we can integrate sustainability into the individual courses, because it turns out most subjects say, Birgit, we already have a very full teaching plan. We can't do an additional course on sustainability. And I said, okay, I get that. So let's see how we can integrate sustainability within the things that you already teach. And that's what this guideline tries to do, that I've also made available for you. That can show you how to better integrate it into the learning objectives and how to integrate those sustainability competencies that I was talking about earlier, the futures thinking, the values thinking, the systems thinking, into a course, not making it the main thing, but having it as one of the things that I teach. Another way to very playfully integrate it, if you say, Birgit, my course is so full, I can't, and I don't have the expertise to teach people about sustainability. I can maybe have 1 hour where people do something. Then using serious games is one of the options. There is one game that is called Rebound Cards. The Rebound archetype cards, where we have 2 examples here on the slides that one can use. And they're a good inspiration for students to think about, oh, what if someone were try to hijack my system and misuse the system for a particular purpose? Or I can have my students think about what types of waste and pollution are created by the system that we are designing right now. Another slightly similar game is called the Tarot Cards of Tech. And both of these are available as a PDF version for free in the links that I provided at the bottom. And here we find cards like the radio star. There's this old song, Video Killed the Radio Star. So when video came, nobody was listening to the radio anymore. Everybody was watching MTV. And the question, the reflection question on the card is, if you roll out your system, which other system does it make obsolete? And here for Mother Nature, if the environment was your client, how would your product change? So I find those a very playful version to integrate sustainability into courses without having to upskill myself a whole lot if I don't have the time, or without changing too much in the course. Now we finally get to the technical level. On a technical architecture level, I can talk about decision maps. I can have a way to document the immediate enabling and systemic effects as concerns within an architecture. And this is work done by a colleague of ours, Patricia Lago, who is not a direct team member of the group, but we've collaborated a lot over the past years. And she is deep into software architecture. She was also developed a sustainability assessment framework that works on a KPI level for software architecture with these decision maps from the slide before. And then Colin over here was leading a work that was explaining how important clean architecture is, because what we see a lot of the time is that the complexity of systems goes through the roof because they were either developed over time and people kept adding components, or it is people that were never software engineers in the first place, but maybe scientists in a different discipline that learned how to code and made it work somehow, but they don't necessarily know good coding principles. So we see that also within the software architecture level, we can have effects in all of those 5 dimensions. And finally, green coding or resource efficiency, you can find a lot of work on in the field. Some of it is by Eva Kern and Stefan Naumann. This is one of the graphics that they have used to show, well, we can talk about the energy efficiency of software. We can also talk about the hardware requirements, and we can talk about where organizational and behavior come in and how this impacts natural resources. And a final pointer to a book, if you would like to read an entire another book about green and software engineering, about green coding and related matters on a technical level. Coral Calero and Mario Piattini edited a book a few years ago on this topic. Birgit, that was a lot of input. So if I want to become a software engineer, what do I do? Stephanie Bates and I wrote an article on the future role of software engineer. This is our concluding slide for today, where we get a bit of an idea, as now so many new demands are on our plates as software engineers. We have to think about sustainability. We have to think about, how does this big rollout of AI influence my job? How does it influence my future workplace? We see the incredibly strong impacts on society by software systems, whether it's through social media or other apps. How does our role change? We need to take responsibility for the impacts that we have on society. And after we've established that in the field, how do we get that into education and how do we get that into standards? And then how can we measure long-term whether we've managed to really improve our profession? With that, we're at the end of the talk. And I thought I had included the Q&A slide, but the Q&A slide is this one. With that, we get to the point of we can ask a lot of questions. We can take questions in the room and we can take questions through Slido. If you're not comfortable with Slido, then we can. Now somebody took it away. Sorry? Yes. As soon as I'm not sharing my screen anymore, I can create a PDF version and and pass it to you to share. Or I can share it directly in the meeting chat. That's even easier. Yes.
Okay. Thank you for your presentation. My question stems from the need for there to be a kind of a United Nations framework, okay, that guides the practice of software engineering or technology, where the issue of sustainability will be taken seriously among nations. Because I know some countries, they are rolling back on this green sustainability issue, like the United States. Their president is not concerned about all this. And if you look at the consumption, all this carbon footprint, whatever, is minimal in the global south. Okay, that is developing countries like in Africa, some part of South America and the likes. But they also feel the brunt of the climate problem. So I don't know if it is possible to have a kind of an organization that will, based on international consensus, that we now kind of regulate how we impact on the nature itself. I know some countries have made nature have rights, but most other countries don't care. And even in Africa, a lot of mining is being done without any regulation and whatever. So my idea is it possible to have such an organization? Thank you.
Thank you. Very good question. So we have, over the past 50 years, 40, 50 years, have had the United Nations kind of taking that role. Because before the Sustainable Development Goals that were established in 2000, we had the Millennium Development Goals that were established, I think, in the late 80s, if I remember correctly. And the United Nations are kind of the biggest organization that we have globally. Now, of course, if some big countries kind of bow out, like the United States of America, that of course puts a bit of a wrench into everybody else's progress, because they are still seen as a very large and powerful nation. I hope that that is temporary. I hope that resolves itself after the next election, but that's my personal view. One of the things that we are very curious to learn this week here is what is most important for the African countries to be able to think more about designing for sustainability, because I know there is a lot of interest. There is also a lot of contextual factors that I maybe haven't understood very well yet, because I've spent most of my life in Europe and a few years of my life in the United States. So I'm curious to learn, with my background and experience that I can bring from Germany, the US, and Scandinavia, what of the things that I find good practices are actually useful here and applicable here, and what of these may just not work for certain contextual reasons that I am not aware of yet. So I think it's both a combination of having a big international organization providing guidance on it, for example, the United Nations, because I'm kind of waiting for the next framework to come out, because the Sustainable Development Goals are scheduled for up to 2030. And after that, we don't have anything yet. And the other piece is every community gets to start on the local level. That's where we can really make change, because having a trickle down from the top doesn't always work. What really makes society change is grassroots activism. And when we get together in our local communities and do what we think matters most. I hope that is a starting point. Thank you for the question. Yes, let's get to the questions on the slide. Summarize the key action to be taken in a few words or highlights. Whew, that's a tough one. Okay. I think the key action would be to reflect, given the things that I've heard in this talk, what of that can I apply to my personal work and my personal circumstances? And that may look very different if I am an industry practitioner, say I'm a developer in a company and I joined the summer school because I want to upskill myself, then as an app developer, I'm just picking an example, how could I apply any of the things that I have learned today to my work? I can think about, where is my app hosted? I can think about, do I have a clean architecture? I can think about, where does the energy come from that powers my service? Is this actually an app that fosters shared understanding and that has a good value at its core? Or is it an app that actually kind of exploits some of those social media things that we've by now learned are not that healthy for people? As a researcher, I can think about, what is the impact of my research a bit long term? If I think beyond my PhD thesis, for example, what effects and what changes can I impact in the world with the work that I do as a researcher? That's what this research framework was about. So I've given you a lot of tools in this talk, I know, very many, and hence you get to pick what is most useful for your personal context and role. The key action is pick what's most useful and do it. Because it's very easy after a talk like this with a lot of input to kind of stall, say, oh my God, that was so much impact, that was so much input, now I'm not sure what to do. Pick the one thing that resonates most. Pick the one thing and follow up on that and change something. And then from there it can spiral. From there it can be like a little pebble that starts rolling and continues the motion. And talk to people about it. So we know that knowledge manifests better or embeds itself better if we can have it kind of recapped in conversation with each other. So one could listen to this talk 3 times and not have remembered very much after, or we can listen to the talk once and then have conversations with the other people in the audience and say, hey, what was most interesting for you? Oh, how are you going to apply it? And then from there on, it kind of settles in more. Second question, how can an educator with no knowledge of sustainability teach it in a software design course? Where should I start? Very good question. Thank you. What I would suggest, 2 suggestions. The first one, the easiest one of them all, is take one of the serious games that I introduced, either the Rebound archetype cards or the tarot cards of tech, and have that in an assignment session with the students. It can be an in-class discussion where they sit in teams around little tables, teams of 3 to 5 people each. That is a good size for discussion. And then whatever assignment is running in the software design course, let's say you build an app for sharing certain resources, then give them the card deck and have them reflect on a number of those cards and then share the reflections in the entire class afterwards. So it's a bit of a group work session. That is the easiest way. And then a second way would be to take the SUSEF framework, to go back to the QR code of the workbook and to try that out in class. It's a 15-page workbook and it walks one through every step that you need to take in the moderation. And the third one would be to look into some of the clean code principles. And it could be any of the papers that I was referencing later on. Maybe the one that Colin first authored that talks a lot about software architecture, and discuss it in class with the students and see what comes back from them. So as teachers, we don't always need to be the experts in the thing that we teach. We need to be a few steps further ahead than our students, and then we can already have a very useful discussion. And often our students bring a lot of input to the table as well. So I hope this helps. Third one, do you have a method to assess student skills in sustainability for a course like requirements engineering? Oh, very good. I like it. So we're going to have a session on rubrics and assessments on, I believe on Wednesday. It's either tomorrow or Wednesday. And we will talk about this in detail. But for a brief answer, the way how I like to do it is anything that I want to assess in a course needs to be in the learning objectives. So when I write my course overview, my syllabus, I write what's the overall objective of the course, and then like what's the topic of the course, and then what are the learning objectives? What do I want that people know how to do or can do or know how to judge at the end of this course? And then for each of those learning objectives, I think about how am I going to assess that? And so if I think back to the sustainability skills, futures thinking or systems thinking, then I will create an assignment that has some of those elements. For example, you are a software developer and you have these two future scenarios. Argue why one scenario is better than the other one, or come up with a third scenario that you think would be best for the sustainability of the design of this particular product. Something like that. And that is something I can assess how well students are able to think into the future. And of course, I need to have given them a few pointers on what that could look like. Specifically for requirements engineering, that could mean if I have sustainability as one of the particular design objectives for the system, then I can assess how well they were able to embed that into the requirements. Say, I have sustainability as an overall objective, and then the students need to figure out how to break that down into particular requirements for the system that they're developing the requirements for. Let's say we develop a university enrollment system. Overall objective is sustainability. Then I can have the students think about sustainability in those 5 dimensions. What does environmental sustainability mean for the student enrollment system? Well, we can think about where are the servers for the system. We can think about where the energy comes from. We can think about how long can we use that same hardware. What about the social sustainability? We can think about the trust in between students and the university and how a system could help with that or take away from it if it's done badly. We can think about the technical sustainability. How do I make sure that the system is going to run for a long time? So that way I can check how well they think about the different dimensions of sustainability within developing the requirements. That might be one of the ways. Okay, next question. How do you implement green software engineering features in the design of AI applications? Now we are a bit outside of my expertise because I am not an expert on developing or designing AI applications. One of the biggest things I have to keep in mind is the enormous resource intensity of AI applications, which means if I want to do this as sustainably as possible, one of the pieces is to provide very good guidance on prompt engineering. Because if I have to ask an AI 5 different times to provide me with an answer because I didn't phrase the question very well and I only realized that after getting the intermediate answer, then I have 5 times those expenses. Whereas if I think about the question really well, and in my head now I'm thinking about generative AI, if I give it a really good prompt, then giving it that prompt once will give me the answer that I was needing. And so I think it's a lot about precision and clarity when we talk about AI applications. Okay, that's all the questions that I see on my question slide. I'm going to repeat. What skills do we as educators need to teach sustainability as a part of software engineering? I think if you read half of the resources that I gave you in this talk, then you're more than well prepared. I think it's really about starting somewhere. So I think the SUSAF framework is a good place to start. The Sustainable Development Goals can even be a great place to start. So I have colleagues at the university in Gothenburg who don't have much education on sustainability beyond reading in detail through the Sustainable Development Goals. And that is a publicly available resource that anybody who also has never ever heard of any of the other resources that I referenced can look into and then have a discussion with their students on how do you think what I or you do as a software engineer affects some of these sustainable development goals? Is there any way how our IT development can influence some of the targets that were defined for the sustainable development goals? So I would say it takes a little bit of effort in learning about one of the potential resources and then getting started and implementing that in class. So I think especially as educators, we sometimes have the feeling that we need to be very expert on something before we dare to mention it in a classroom. Whereas I think if we have our first building blocks, okay, I've learned about the sustainable development goals, I've learned about those 5 dimensions of sustainability. So now I can have first conversations with my students, because as we have these conversations, we have new ideas, we get new pointers, and we will also learn more. So I think that's a good starting point. For green and sustainable software development. So we are developing a course on it. We don't have the materials ready yet. There is a colleague in the UK, his name is Adrian Friday, who has partially made a course available online on green computing. It is not only software engineering, so it's a bit bigger scope than software engineering, but we can provide the link for the resources that he has available publicly. And then there is also another course in the Netherlands taught by Luis Cruz, who has made most of his resources available. And I believe that one is a software engineering specific instance. I have the link on my computer, so we can provide both of those. And I have a YouTube course on IT for sustainability. So it's not only specific software engineering, it's also a bit wider. But that might be a very useful resource as well, and we can provide that link too. We have a question here in the room, Shola.
Okay, good morning. My name is Joel, representing the School of Yabatech. And my question is, what are the biggest policy gaps holding back the adoption of green software practice in sectors like real estate and urban development in Africa? So what are the gaps there? So
What are the, let me repeat it out loud. What are the policy gaps for the adoption of green software? Oh, in real estate, that was the one that I missed. I am actually not aware of a lot of policies for sustainable development in specifically technology. I'm not a real estate expert, so I can't answer that part of the question, to be honest. And I would say the policy gaps, therefore, are huge. We don't have a lot of policy. We have GDPR, which is concerned with privacy. We have, I believe, we have a First AI Act that is a useful one. We don't have much specifically on sustainability. And some colleagues of mine around Stefan Naumann and Eva Kern, who we also referenced in this talk a few years ago, they tried to get to a energy efficiency certificate or classification for software. The same how my fridge at home can say class A or class B or whatever. They tried to get a label like that for software, but it didn't work because software develops so quickly and software technology develops so quickly that they would always be behind in adapting their standard. So there is very big policy gaps. Thank you. Yes, 2 more. Where did the other microphone go? Oh, you have it. Okay.
Thank you very much for the lecture. When I look at sustainable software development, it's all about, how do I make the software efficient? How do I run the software? Are there any studies on how software supports sustainability in other infrastructure. I want to give an example. If I want to give a lecture, and all my students have to drive, they have to drive down to the lecture hall. Isn't that don't they consume more energy rather than take it online?
Yeah.
Is there any study like that? Because if you are talking about sustainable software development, you should also talk about how we can use software to reduce the energy expenditure, the way you use infrastructure, other kinds of infrastructure. So if you can use software to substitute for things like, oh, I don't have to drive down to class, to college to receive my lecture, that is also, I think that's also part of sustainable software development.
Yes. Yes, it is. So this goes into impact analysis across several dimensions. One part is the energy. We could all have a virtual university. We could all learn from home. We don't need to get together anymore. We all have a computer. If we all have reliable internet at home, if we all have a strong enough bandwidth to be able to hold a conversation or to listen to the talk properly, what do we not get? People. As humans, we're a relational species. So what we've seen in studies that were looking at how a majority of people in certain countries was working from home during the COVID-19 pandemic, we saw a lot of social decline. There were a few software developers who were really thriving because they were very much introverts and they were happy to not see anybody and just be with their computer. And there were many who were feeling their life was really deteriorating because they were missing people around them. There were, of course, also other factors in terms of, are there other people in my household that I need to take care of? And so am I more distracted if I work from a different place? But so there is different types of impacts that are very hard to balance against each other. And I recently gave a keynote talk in Barcelona on the topic of sustainability. And I wrote down at the very end, my very last slide was the carbon impact that I spent to get to this conference, to fly there and to give that talk. And that also holds for coming to Nigeria this time. It's a long flight, so there was a lot of carbon emissions for me to come here and present this topic. And whether this was worth it, I would theoretically know in about 10 years, depending on all the actions you have chosen to take after the summer school or not. So I don't really have a way to assess it, but the way how I like to think about it in my head is it more beneficial? Like, are the positive impacts from having this in-person event bigger than the negative environmental impacts that are being caused? And that scoping is very difficult to do. So we would have to look into a very detailed life cycle analysis. And there, the scoping is usually the challenge of how could I possibly measure the actions that you might choose to take in the future based on what you've learned in this talk? And so I don't have a very good answer for you. It depends on what you're going to give in that lecture and how much inspiring conversation you have with your colleagues after the talk, or if it's more like, I'm going to talk and then I'm going to walk away and we don't speak about it afterwards. So yeah, there's a lot of different impact factors and a very good question. Thank you.
Thank you very much. I think part of your lecture, you make reference to some of the reasons why we need the sustainability. And one of it has to do with depletion of the ozone layer. And I remember during my school days, we have been talking about ozone layer depletion. And I found that that's almost 35 years ago. I began to wonder how sincere we are with this. Dr. Rufai just gave example about the current, well, I don't want to make mention in the developed countries, how national attitude they have. I remember when I presented my first paper in 2003, and when we talk about the green computing, you have make mention, and then one of the things that switch off your light,
But it's only when we put it on that we know that even there is light. And those days, thank God things has improved. So I just want to ask, how sincere are we about this sustainability? Thank you.
Yes, very good question. I like challenging questions. Like, essentially, the question is, does this really matter? And I would like to refer back to one of my previous slides to give the answer for that. I'm also going to share it on the Zoom again. Here. So, yes, in the 90s, when everybody was talking about the ozone layer, we kind of fixed it. So there was this big ozone hole over Australia, close to Australia, and it was due to some of the chemicals we used in our fridges at the time. Those gases are no longer used. We've stopped blowing them into the atmosphere, and the ozone layer has recovered pretty well. So I would say that is one of the few areas where we have done really well. We've recovered our ozone layer enough so that it's not even in the news anymore because it's not that big of a concern anymore. With some of the others, it's a big concern. So the way how nitrogen cycles are influenced by all the fertilizers that we put into the ground for large-scale agriculture is very concerning because we're depleting the soil and it can't regenerate enough to produce more food. And sometimes it is so dead that it can't regenerate at all. So we've been tremendously overusing fertilizers in agriculture. And that can be reversed, but only if we really take action. If we try to continue to do farming in the way how we currently do it, we're not going to have enough food for everybody in a while. If we apply some regenerative farming principles that are also quite available to large-scale agriculture by now, then we can make a significant change. So we can also reverse some of the effects here. Loss in biodiversity. Sorry, where is it? Yeah, genetic diversity. It's very unlikely that we can reverse that. We're losing so many animal and plant species each year. It's going to be very hard to reverse any of that. And it's just those factors that destabilize. So with the ozone as an example, that's one of the 9 boundaries, and it's one that we've kept reasonably well. The others are way more dire. And so, yes, the situation is pretty dire. And the trouble with it is it's not tangible because we've destabilized the system. So we could have some more extreme weather events starting tomorrow or this afternoon. Nobody can predict it. It might just happen. And since it's not directly in our face yet, the consequence, we're wondering whether it's really that dire. So anything that we can't touch seems to be a bit too far away, and we can't all get a very good sense of global scale challenges because we are physically in this one determined location at one given point in time. But yeah, the situation is pretty dire. Say not only me, but a lot of researchers that published around the planetary boundaries. Thank you. We had one more question in the far corner, and then here, and then here. Where did, there's the microphone.
Good day, everyone. My name
Good
is
morning.
Abiola. Thank you for the lecture. So I have 2 questions. Number 1, what effort are you making to get the buy-in of the big tech companies, especially those who have products and infrastructure that generate such volume of energy that can make impacts? Then number 2, how has been your experience promoting sustainability and software engineering?
Thank you.
Thank you.
So for the first question, what am I doing about the big industries? Well, whenever I get a chance to talk to an industry partner, I mention these things and I'm curious about what they do because nobody likes unsolicited advice. That has never worked. Whether we think about doing more sports or stopping smoking or whatever it may be, or a big company about how they do things, we don't like unsolicited advice. So my preferred way to go about it is to be very curious how they handle certain things. So I might ask them, so what do you do in your company for sustainability or about sustainability? And then I might often get answers like this greenwashing thing. that we spoke about earlier. And then I ask, well, do you think that carbon trading is really a good way of going about it? Me paying somebody else to plant a forest and me continuing to do the emissions. So sometimes interesting conversations come out of it, but also I'm just one little professor. So I don't know if I can have a big effect on those big companies. I think that's where we sometimes need the policymakers to come in and say, this is the law now. And for the second question, my experience in teaching software engineering for sustainability has been very positive in the sense that whenever we get to an audience, they're usually curious about it, want to learn about it, and think it's relevant. There is a bias in there. If you do not care about the topic of sustainability at all, you wouldn't sign up for the summer school, right? So my personal experience is pretty biased in that sense. There may be many people that I don't get to who say, I'm not interested. Since I'm only one person with limited capacity, I am happy to teach the ones that are willing to listen. That's what I can do. Thank you.
Thank you.
Like these two? Is that okay if we take those two?
Okay.
Okay, good afternoon. I'm Obi Onyedikachi. So I have two questions. The first one is, can policy in somewhere like America now, that there are so many, I think, there are so many data farms and data centers and all this, can the carbon they emit there, can it affect we here in Nigeria? That's my first question. And the second one is from the first one, which is in Nigeria here, I don't think, I stand to be corrected, but I don't think we have so much software applications and software intensity that can deplete our own ozone layer covering us here. So is it not right for us to focus on the things like Lagos here now that is busy, that there are so many sport cars on the road and all that? Is it not right for us to focus on it is actually costing our own? Even fertilizer is expensive. So if you're speaking about fertilizer, we cannot even afford fertilizer to deplete our own ozone layer. So it's probably the people in America and other developed countries that release fertilizer that. So my first one now, that fertilizer they're releasing there, can it affect us here in Nigeria? Yes. And second one is, don't we just focus on what can possibly deplete our ozone layer?
Thank you so much. So for the first one, I would say there are some things that may affect you and some things that won't. If, say, in California, they blast a lot of emissions into the air, then primarily the local people will have the effects of it. If in many other countries, we blast so much stuff in the air that it further destabilizes the climate of the entire planet, then all of us around the globe will feel it. So it depends on what type of impact we're talking about. And then for what can be the focus here, I think we have a big chance here in two ways. So one, I've seen in Lagos, in Nigeria, and in large parts of Africa. I'm not familiar with all parts of Africa, by far not, but I've seen a lot of push for development and a lot of progress in IT. And our hope is if we can bring the sustainability design principles in early, that all the development effort that is now being poured into it and all the passion and wanting to achieve more is done in a more sustainable design way, great, mission accomplished. As for the other areas of sustainability here, that I'm not that much the expert on. I think there's these big infrastructure challenges. We live in this giant city here and it's very hard to get through and it delays with traffic and also that. So maybe there can be future solutions for that. Because the person owning the sports car may also not have the most fun standing in their sports car in a traffic jam, right? So maybe we can convince them to use some more sustainable means of transportation. And me being an educator in software engineering, I think mostly about what can we as software engineers do. There's other people who are more specialists in the other areas, and I will let them speak to that. So thank you. And then very last question at the back.
Yeah, thank you. I want to know the cost benefit analysis for this green software engineering, since some students may want to take that up as their field.
Mhm.
And of course, they also have to look at the marketability. How marketable are they going to, what is the market strength if we have students that have specialized in this green software engineering, so we need to know the cost benefits if there is on that. Thank you.
Very good question. Cost benefit analysis. So we're talking economics now. There's a lot of consulting going on in economics. What is the consultant's favorite answer? It depends. So it depends on what kind of practices we wish to apply. There is small scale changes that I can do anytime that won't cost me much. If I think a little bit harder about the design pattern that I use in the system that I'm designing, I might actually save a ton more resources, and it might be a very positive cost benefit analysis. If I think about, should we really build that new server farm? Or should we not? If I think about maybe not taking a business opportunity because it turns out it is environmentally very unsustainable, I might make some money in the short run, and I'm choosing to lose out on that business because I see how much negative environmental impact it has. And I can't come up with a very good example off the top of my head right now, but you get the idea of it. So there is both the cost benefit analysis for the company, and then there's my personal moral and ethical responsibility. Do I choose to put a priority on what is good for the environment? And we're also aware that there is privilege associated with being able to make such a decision. Sometimes we might not see ourselves in a place where we can take the decision, are we going to do this or not? But I might have to do it to put food on the table for my family, to keep my job, even though I don't agree with the choice. Whenever I have an opportunity to make a choice pro-environment, then I would hope that that's where our moral compass guides us. I have not seen a lot of empirical studies that would summarize the cost-benefit analysis for taking the more energy-efficient options. Where I've seen them, they go hand in hand. So for energy efficiency, the case has been made at the danger of potential rebound effects. For more sustainable server hosting, for example, if I choose to host on a green server, I would describe that as something that is fueled by renewable energy and something that is cooled in a sustainable way. That might have additional costs because it takes into account the costs that the others don't pay for the negative environmental effects they cause. So we have a problem in our economic system here that we have these things that we call environmental externalities, but they were never external. We've just decided as economists to exclude them from our calculations because it benefits us for our bookkeeping, but not for staying alive as humanity on this planet. So once we fix this economic mistake, it will always be the more cost-effective analysis, more cost-effective answer. Thank you so much for the question.
Sorry, good afternoon. Yeah. So I have 3 questions. The first one is, how do we evaluate the performance of these green software engineers? We are engineering. Do we have available tools? And because we know we have a responsibility of embedding the environmental features into the software. So we need to know how we can evaluate the performance. Then the other question is how reliable it is this green software engineering. We've been talking about sustainability, but we've not been talking more on how reliable it is. And I want to know the correlation between both of them. Then the third one is, like Nigeria, there was a speaker that spoke about, let us talk about our local problems. And yeah, I'm looking at we as maybe engineers, we cannot work alone. There's a limitation for us to see the effects of us bringing this green software engineering. Is there collaboration between like sustainable officers to make people, because in our system, if it's the work of the developers, the engineers, you will not see the effects. But we need people to also collaborate with us in terms of compliance. So what are we doing in terms of collaboration? Thank you.
Okay. Thank you. Let's see if I can remember all three. So the first one was KPIs, the second one reliability, and the third one, what can we in Nigeria do? Okay. For KPIs, there is not a fixed set of KPIs for these practices yet. I think there are several research groups working on this, and it is work in progress. It very strongly depends on where they get applied. So for example, if I use green coding practices as an energy efficient, good design patterns and a couple of others for designing a little app or for implementing a robotic system that runs a giant manufacturing plant, like those are very different types of systems. And so it's hard to not compare apples and oranges. And hence, I don't think we're going to have one overall KPI framework. We will have them for different types of systems, and that is work in progress. For the reliability of these practices, I've seen positive outcomes in any of the ones that we applied. I have yet to see cases where it kind of went the opposite, like we tried these practices and actually got worse than before. I haven't seen any of these cases. It doesn't mean that they don't exist. And then in terms of being able to foresee the impacts, I don't think that is specific to Nigeria. That is the same for anywhere else. Like we have trouble as individual developers to foresee what are the long-term impacts of the system that I'm creating. And that was one of the main motivations why we developed the SUSA framework, to help people with these sets of questions to judge a little bit better, if many people are going to use the system over a few years, what are going to be the long-term impacts? Yeah, so that's what the SUSAF is for, I hope. Thank you for all the questions. That was a lot of questions. Dr. Rufai, thank you so much for letting me take a few more questions.
Thank you very much. At this point, do we still have more questions? Okay, so yes, so those online, if you still have questions, you can send it, then we respond to that later. So a round of applause for our guest lecturer for a well-delivered lecture. Now, having looked at that, I think he has talked about the whole essence of sustainability, talking about donut economics up to sustainable informatics and the issue of a rebound effect that is linked to economic efficiency. That is when you come up with something like computer miniaturization, and you still have many people using computer. You're solving a problem, then creating more problem. So she now came up with a Calscronia Manifesto, which is a framework that led to the sustainability awareness framework. And we have seen other issues discussed. So thank you very much. So the next thing we're having is for the participant to fill the form. Okay, there's a form that we go around. We also have the QR code. So after that, we go for the tea break. Yes. So that is it.
Thank you.
Thank you very much. So can we project the QR code? Please do help us fill the QR code. How are you? Yes. The QR code. For our participant online, you will get a link for the QR code, for the form. Please kindly help us fill this for feedback. Yes. Yeah, okay, you can fill online, but the QR code, there is a form. But if the QR code, no. It's part of the sustainability, sir. That's why part of the green company. It's green. We want to save the planet. I mean, please, let us just do this for just 5 minutes. And from there we move to the lot of food. And yes. How many people? Yes, can you send me what? Okay, I will. We implore our online participant to help fill the form. It will assist us to serve you better. Please, we can go for the tea break now, and we are to resume in 30 minutes time. That's 1:05. 1:05. So for our online participants, we are going on tea break for 30 minutes. So we resume in 30 minutes time. Thank you very much. Are you done? I can go ahead now. Okay, so we move on to the next session, and it's going to last for 1 hour. It's on sustainability mapping exercise, reflection on teaching practices using 5 dimensions of sustainability. So we call on Professor Colin Ventus on this. Professor Ventus? Yeah.
Never mind. I'm trying to work out what the time is. It is actually good afternoon. So welcome back, everybody. My name's Colin, and I'm going to lead the session where we're going to consider how we map teaching practice to the dimensions of sustainability. So this is a hands-on practical session where we're going to get you to think about this as potentially educators and practitioners, okay? So I thought we had quite an interesting discussion at the end of Birgit's keynote speech that led to a whole set of things about what should I do, okay? So this is an opportunity to think about how we might bring those things to reality rather than them just being abstractions, okay? So I thought we would begin just by a quick review of what we thought about in terms of sustainability. Okay, so these are sort of typical words that we tend to see when people ask, what do you mean by the word sustainability? And one of the key challenges around this is that in many ways, the word sustainability has lost its real meaning. And the question is, what do we really mean by that word sustainability? And how do we go back to its absolute core essence? Because if you listen to virtually anything these days, the word sustainability will come up. Any kind of news broadcast, any kind of speech, and that word sustainability will come up and we'll go nod, nod. But I've absolutely no idea what they're really talking about. Yeah. So I think it's how we sort of reframe what do we mean by that word sustainability? And is there potentially a better word that we might want to think about as computing educators and practitioners? And how might that relate to clearly defined views of what sustainability could be? So this is just to kind of remind you about what you thought about it. So a lot of the stuff in there has got to do with things like longevity. Some of the words that seem to have disappeared were to do with durability, long living, preservation is a good one. You know, these are kind of sort of, how do we sort of build that ontology of semantically related concepts that show us what the word sustainability means? So the second thing that I wanted to do to kick off this session was just again to remind you that there are different types of dimensions. Now, we've settled on 5 as our group, but there are many different types of dimensions that could be factored into this, okay? So the first thing I want you to remember is this is at least potentially a baseline, and there may be other dimensions beyond these 5, right? So we're not just limited to 5, but you want to think about, at least in terms of this exercise, this is what we mean, okay? So I can't remember whether Birgit and I put these in order, but we can always come back to this slide. Okay, so this is the kind of the understanding, the definition of what we mean by these particular dimensions when we talk about that word sustainability. And I often refer to that sustainability has its dimensions, and I'm interested in the impact on those things. So I'll go back to the first one. So when we talk about the environment, we're talking about natural resources and to promote long-term human well-being when we think about the environment. So what I want you to think about over the next 5 minutes is to think about how we can map teaching practice to the environmental definition dimension of sustainability. Okay, and that raises a couple of questions. The first thing is, what is teaching practice and how do I understand that? and what might be the relationship between that and this concept of an environmental dimension of sustainability. Okay, and then we'll see what your kind of views on that are, and then we can have a shortest discussion. Given the fact that there are 5 dimensions, we're going to have to kind of keep a real grip on the time for the discussion. Okay, so let's see what your views are when we think about mapping teaching practice. So what do you do as practitioners? If you are the recipient of teaching practice, so potentially you're a student, what type of teaching practice are you exposed to? And how might you then think about that from a sustainability perspective with a very specific view on the environmental dimension here? So have a think about this, okay? There are no wrong answers, okay? Don't be shy. Yeah, and Birgit, of course, has made the excellent suggestion that perhaps you could work in groups, okay? So you might want to get together with the people you're sitting in proximity to. It can be a larger group, so you can simply turn around, yeah, and face the people behind you. And people can just sort of reorganize themselves so they're in slightly bigger groups on their own, rather than be on their own, okay? So, I don't know, do you guys just want to turn and face each other? You face each other, and then perhaps the chap at the front there, he could just switch seats and then he can join the group at the back, yeah?
In software or just sustainability in general?
Well, we're thinking about that in the context of software engineering. Yeah. So this is about potentially computing. I mean, you can look at the broad spectrum, okay? Perhaps a better word of characterizing this is under the word, the label of computing. Yeah. Which has a very broad perspective. But if you want to think about that in terms of software engineering, as opposed to the other end of the spectrum, computer science, which are not the same things, but there are overlaps between them. So you can, depends on which lens you want to pick. You could take the broad view of computing, or you could take a slightly more narrower view where I'm thinking about this from a software engineering perspective, given the fact that this is actually a summer school on green software engineering. Yeah. But there's nothing stopping you from discussing it in the broader context. Yeah. And if you really want to scale it up, you could think about ICT, okay? Information communication technology, which is some higher level view. Yeah. You can also see what other people are putting online. So you look at what they're saying and reflect on whether you think these are bad ideas. So Think about sources of inspiration. Think about what are teaching practices within a particular context. Think about what we mean by this word environment. We go back to that definition of what we mean by that. So that's kind of your frame of reference for it. Yeah. So we see that environmental. That would see the environment has the idea of protecting natural resources. Yeah. And ultimately that might also be related to the idea of consumption of those resources. Yeah. And then you have, you know, what are the natural resources that are available to us?
The easiest one that comes to my mind is developing And again, based on like what just to add to what you just said now. I also like you talk about curriculum review. So we talk about curriculum review. We talk about curriculum review and how the people who impart the knowledge, let's say the instructor can also teach the student on how to make sure that they are putting in, considering the environmental factors. So I want to make an example. So for instance, now let's say an oil rig, maybe a mining on oil rig, and students were tasked to come up with solutions for this particular purpose, a mining or oil rig. You know, most times when students come up with solution, they might not really consider the environmental effects. Them is just coming up with the solutions. But now in this case whereby the teaching method and the curriculum is also going to contain things that teaches them about how to put in the environment into consideration when coming up with solutions. I don't know if you understand.
Yeah, so that means you are trying to make them conscious.
Yeah, like in the curriculum review, like what he said. So I'm taking up from what he said. In the curriculum review.
Okay, and something you might want to factor into this, okay, is what is the Nigerian perspective, or potentially what's the African perspective on this, right? So I think that's a really kind of important thing not to lose in the discussion. So we had quite an interesting chat over the coffee break. Okay, right, here we go. Apologies about that. So, one of the things I'd really kind of like to emphasize is that we do not lose the African perspective, okay? And I think that's really kind of important when you're thinking about, you know, how might this particular institution, you know, with the establishment of a new software engineering program, begin to integrate some of the very interesting ideas that are coming through. But is there something that is uniquely Nigerian or uniquely African about all of these different types of dimensions? Because in many ways, what we would need to be mindful of is that we're not imposing a European perspective on the problem, okay? So I think you need to really kind of keep that view in mind. And in many ways, we could really kind of re-emphasize that question a little bit so you remember not to lose the African perspective. So is there something unique in the way in which that African institutions teach that is perhaps somehow slightly different? And always a good idea is to think about who are the stakeholders in this. So that's not just, you know, teaching staff, that are the students who are going to experience this. Yeah? I just want to emphasize that particular point, yeah?
And there are some rules that one need to actually ensure that you stick to. You understand? No repetition of code, make sure that everything you are doing is not too loose and at the same time is not too tight. So an average person that wants to design, your first thing is how it works. You don't care about it. So that's the reason why we have version 1, we have version 2, we have this, and we have also to so now bringing that to the classroom, that is where you're supposed to get the fundamental. And another thing is that there is an algorithm, you understand, but students, they run away from it. Somebody that have knowledge about it, if at all, the code, at the end of the day, they will be able to wrap it up. You understand? So now coming down to the classroom, there is a way we can encourage them, because building is So when there is code repetition, then the energy increases. So
I like your point. So when we are talking, we will give you response back to the question that I'm sure it's going to have questions. Say something from a perspective. You can bring that perspective. Now the perspective I want us to do, because what you are saying is global, but you've not said that there are sustainability much. You have only said that in one application from what I can deduce. What I raised was around sustainability. Now, first of all, let's establish what mapping of teaching would that be the environmental dimension of our study of our environment. Now, we're not limited to our environment, we have made it more easier. In Nigeria, we have with regards to sustainability, ensuring that we meet some of the framework we have this conference or workshop was that by 2060, sustainability has only right through auditing in our policy formulation that even aviation you can begin to try. You can begin to see even things that seem to be waste to be paid for. And I'm going to pick from environment. Thankfully, it's someone here. We have a center here. I'm going to start with that as my example. It is part of this called entrepreneurship. I don't know if you understand. When you talk about sustainability, sustainability cuts across many confines or many of the department incomes. That part that I mentioned, a level of growth in their new teaching. Why am I saying this? Realize that students have latent creativity here. Things that have challenged students to come up with sustainable solutions because that can solve the problems of economic, social, and help you to see what are financial around this even what that means is that we want students to be overly dependent on what will come from their culture. So your own example that can help their teaching in job creation, in environmental stability, is anything that has to do with making a living, do it, and the best is where to keep it for. Now, I want to see in the area of environment. We know that we use a lot of tires, right? And there's not many people at school that tell us when you're trying to make sustainability to out of school, we can from tire, which is supposed to be like a waste product. After it's been used, we can bring that home and it can help increase SMEs growth. And when you're talking about SMEs, everybody's today now, whether we like it or not, has grown so considerably that I think about over $1 million has been injected into Africa in terms of sustainability challenges across the big and west sub-Saharan Africa. I'm sure you all have seen the news in those situations. So these are the things that that's what he's saying, that we should limit it to what we can do for our own environment. Because we're not trying to force what is happening over there on us, but tell us what some of these environmental dimensions have actually had an impact on our economy. So on one part, it has me, I want to stand on the opinion that it has helped grow. It has also helped us to open our ideas to other areas where we can make a livelihood. Not many people over the years will say, I remember when we were young, there used to be these Guardian shoemakers who used to use tires to make slippers. I don't know if you see them there. Tires to make slippers back in time. Even though it was tacky, it was a bit tacky over the 80s. It was a bit tacky, but these days, there's been a lot of growth. Now we see people make comfortable chairs.
Okay, so I'm going to draw a line under this particular bit of the discussion, but what I want each group to do is give us one point that came up in the discussions, okay? So since you've got the mic, you can go first.
Good afternoon, everyone. All right, I've looked at the issue, the question raised about how we can consider teaching practice software in engineering from African perspective to environmental dimension of sustainability. I think it's almost important that we put this to bear, that in Africa, particularly in a nation like Nigeria, or let me bring it home to a place like the University of Lagos, where in the last 10 years, we seem to have heightened the level of innovation and sustainability amongst our students. As a matter of fact, there is a particular office called the Entrepreneurship and Skill Development Center. The whole idea of setting up that hub is to create some level of innovation, sustainability, and creativity amongst our students so that they don't go and look for white-collar jobs. So what that means, if you're bringing this to this particular question, would be I think in the last couple of years, in fact, as a matter of fact, I was looking into something recently where they have spoken about waste and how it's affected us considerably within Lagos environment. Lagos being a cosmopolitan state, we do not have many dump sites. If you're coming to Lagos via the normal interstate route, there's a place called the dump site, Olusosun, that's what it's called. If you go in there, you see that people have not really helped. Yes, we have several wastes, but those wastes have not been brought to the level to which we can sustainably manage and turn those wastes into things that can make good materials of. For instance, I want to bring the idea of tires. Tires has become something of waste. In fact, for many of the companies, like those into the cement, those into the bottle company, the bottling company like Coca-Cola and all of that, some of them now go to take some of this waste, because this waste, we know that by the time they are burnt or decomposed, they deplete the ozone layer. So what they do is that they pick these things and they make good creations out of them. So in other words, it solves the problem of trying to improve our greenhouse emission, or trying to delimit that so that we can have a green and clean and safer environment. So that is one part you can solve the problem around environmental sustainability with engineering. So with the creation of tires, picking tires and creating something like a beautiful architecture of materials out of it, sofas in the rooms, tables with use of tires, it's a way to say that there is no waste. Our waste is our power. And that is because that's what we understand within this conference. We do a lot of waste in Nigeria, but we don't know how to manage those waste in the aftermath. So when you bring all of these things to bear, you agree with me that once we start to look in the direction of seeing waste as our power, as our source of wealth, then we are solving a problem, and that will bring about improved sustainability in that area. Thank you.
Okay, that's very interesting. Something from the next group.
Hi. Okay, so on this table, we actually outlined 3 points on integrating the environmental components into SE. So one of the first things we talked about was providing adequate awareness and sensitization about how you can integrate sustainability in AI, because in SE rather. This is because instead of having, in our local context now, we don't have regulations and policies that guide sustainability in SE. So, but in place of that, we can provide more sensitization and more awareness to both developers and teachers, educators right now, about how, or the role of sustainability in the whole, and this would actually trickle down the entire system. So when you have people who are both teaching and then who are both integrating sustainability. The other thing we also talked about was providing having efficient codes. So instead of you developing codes now that are very long, you look at ways to write shorter codes that are more efficient and will use less energy, time, and all that. Of course, in terms of being sustainable. The other thing we talked about was providing an enabling environment, for people who are in that space. Thank you.
Okay, thank you very much. Pass the mic along.
You speak, man, you have it.
Okay, when we were considering mapping of the teaching practices, I brought up the issue of how to map what is learnt in books with what is seen in our environment. And I used my kids as an example. When they were taught alphabets in class, they were not taken to a farm to show them what some of those things were. The apple trees, they saw horses, goats, and the rest of them, and they were telling them how those were the things that they were learning in class.
Then I also mentioned how I try to use things around me to illustrate concepts to students so that it's easier for them to relate to it, and it will stick longer in their head. And also practicing of, recycle sustainability is how I put it. Like when we have the big Salah festival, rather than throwing the dung and the internal waste away, we just dig portions within our home gardens and put those waste inside them so they fertilize the land. So that's it, as well as she also mentioned recycling of the PET bottles and using them for projects, which some of our students were exposed to in the last few years. And Dr. Adelopo is also the one overseeing the sustainability section for that kind of project also. So, about you mentioned something.
Okay. All right. In addition to that, I also mentioned the use of wearable devices in the farm to help monitor the BP of the farmers, the heart rate, in order to reduce accidents on the farm. So that was also mentioned. Then relatable materials for teaching, what the student can really relate to that will enhance their memory in teaching them. Those were some of the things that was mentioned in there.
Great, thank you very much. Have you passed the mic back?
Okay. Am I to present that? Okay. Okay, so, all right, so I think, what did you talk about? Sorry. Okay, can you say it? Can you say it?
Yours, is it the one you said? The one I wrote. Okay, so one of the things we suggested is for us to include practical demonstrations in the software engineering courses. For example, after teaching them the theory, we may try to come up with an app idea in the class. So as all the students in the class can work on it as software engineers, considering the sustainability dimension. So the educator can ask them to come up with different ideas for that particular app where sustainability can come in. So that will encourage.
Okay, another one of the things that was discussed was in Africa, a lot of students have problems with funding for research. So the idea was that develop a workshop for a lot of people to come. We develop a project that has sustainable ideals and goals, and then we evaluate, and then when we decide that it's valuable enough to sponsor, then they can go ahead and do their projects. The African perspective is that they are going to be solving African problems. So if you go to Lagos Island and you see that, oh, the air quality is terrible, let us develop a sensor that helps us to monitor it, and they come and they say, okay, we're going to develop an app for that, then we can sponsor the research that goes into that. So, yeah.
So one of the things we also looked at is we should create an orientation in students where they see, where they are entrepreneurs in developing sustainable software and solving sustainable development goals. We give them the orientation that, look, you can actually be an entrepreneur doing this kind of thing. That's the other thing. We should give them that kind of mindset. Yeah.
Okay. Okay.
Sorry, sir. Before you finally solve it, we want to have this.
No. Oh. No, let me finish. Yeah. I think we're also talking about the African perspective. We have to be mindful of the infrastructural deficit that we have, especially when we are low resource in terms of infrastructure. So problems that students will solve will be done against this backdrop so that it will key into the sustainability agenda that we're trying to promote. Thank you.
Okay, we'll take one last comment and then we'll move on to the next one. Yeah, after this one. Yeah.
Okay, so I think the goal is to actually help students and developers to be actually eco-conscious when building a software during the software development cycle. But that's where you said something about in the Nigeria's perspective. I think on environmental sustainability as well. I think they should account for local infrastructure as well, and also awareness gap, and also talk about economic realities and something that is actually visible in the economy as well. And I think that's actually based on the perspective, Nigeria perspective. Thank you very much.
Great, thank you. Okay, so just to pick up on a couple of themes that I think have cropped up in that discussion is thinking about theory and how you relate it to actual practice, and then giving real-world environmental problems to think about how those things are solved. And then a takeaway from this one was about what are the skills, the practices, the knowledge required to write the implementation aspect of the code base. And then again, to come back to kind of a sort of a broader view, the environment in which to kind of support all of that. Yeah. Okay, some really interesting stuff. So let's move on. Okay, well, I think in the next session, what we'll do is we'll give online the opportunity to feed back in. Yeah, okay. Okay, so just as a reminder, we're going to now deal with the social dimension. So this is how we think about this: fostering community cohesion, trust and equitability, access to digital services, okay? And then how might we think about that now? So you can see that Birgit and I have updated the questions to really kind of emphasize this, particularly within software engineering, particularly with an African perspective. What are the mapping, the teaching practices? How do we begin to map that? And potentially, if you think about what you did in the last exercise, how are some of those things transferable across different dimensions? Okay, so we're going to give you 5 minutes again, and then we'll quickly go around the room and online in particular to get some feedback. Okay, so stick within your groups, have some kind of discussion. Think about what you said in the previous exercise and how is any of that different or is it the same? What are the things that you would change? What are the things that you might add? Okay? Right. 5 minutes starting from now. So we'll leave the definitions up there because I think the definitions are a good frame of reference. We all understand what the question is. How do we map teaching practice in software engineering in an African perspective to that dimension? Yeah.
If you haven't taken a photo of the definitions, please take a photo of the definition so we can put up the question again. Otherwise, the online participants can't answer the question. Thank you.
ti pé àǹtí ṣe yí ni mo ti bá àǹtí ṣe sọ̀rọ̀ mo tún bá Bella sọ̀rọ̀ it sounded fine she said ìkíní yẹn ò really do me as in it's not really pay me but still on still let's take her to clinic in kind of pharmacy even look at it fine.
Change the view camera.
You see this minister of power, he's supposed to flog an Oraimo code. Honestly, it's obvious in his even in his look. Being a one kind LGBT person, you don't see him. No, he says that we are the one to pay for the debt, the 4 trillion debt. Nigerians are to pay. Nigerians, that Nigeria should prepare themselves to reflect the true amount or something like that. That's what he's saying.
Well, I think we've not been paying abuse long before.
I don't know.
If we have been paying abuse, so somebody is busy somewhere.
Good. Oh, you sure? Okay. No, ó ṣe kí ṣe òun ni bàbá yẹn lò. Ó wà lórí tébù kan mẹ́rin.
Wọ́n lè ti wà lọ́nà ọ̀pọ̀ tí mo kọ̀ tí mo kàn tó lò. But my message on the WhatsApp, we got forward part of the one. Bóyá màá wá sí department sí màá send ọ̀rọ̀ mi màá message mi sára sí send to me. This time I know I send it to you. I send file to you.
One question. Yeah. Is the Zoom connected to any speaker? Is the online? If you want something you can. Yes. Yes.
This time I first I did department when you check out results in
okay. No problem. I know my sent for the next one. My sent file for the next one. Yeah, you can.
Okay, I'm conscious of the time. So let's have one from one group in the room and then one from online, okay? And since this group has the mic already, then they can begin. You need 2 more minutes, okay. Okay.
All right, good afternoon. So I have a case study I'm using the University of Lagos as a case study. So University of Lagos is an institution that have people from different backgrounds. We have people that are rich and people that are middle class and poor. So indigent students, people that cannot afford some things. So I am a student entrepreneur. I come up with solutions to problems. Basically, I started from here, University of Lagos. So in building a mobile application for students to use, for them to study, during the ideation stage of the project, we decided that there should be an offline and online mode for the mobile application. So for students that could not afford internet connection at a particular time, should still be able to access the digital products. So we are trying to make sure that it is the services, everyone have access to the product and no one is left out. So inclusion is being considered. Thank you.
Thank you very much. Is there a comment from online?
I think from what we've heard from some of our online audience, the key thing is to educate students about social responsibility and to take the societal impact into consideration, and things about equitable access to digital service was a key theme when talking about social sustainability dimension.
Okay. One takeaway from the comments that I've seen up here is that if we're thinking about how do we teach software engineering, we need to think more broadly beyond just the technical skills that we give software engineers. And you know, that's come through quite strongly in some of the comments, right? So talking about the word empathy, how do we develop empathy in software engineering students? How do we get them to understand different types of values that might be important? So a kind of a key takeaway from thinking about this idea of social responsibility, particularly if we think about how do we teach software engineers things, is that there needs to be some element of the program that exposes them to things that allow them to think about being, you know, sharing particular types of values. Because what we do is that we bring our own value set to these particular problems. But actually those values might differ. And how do we develop, you know, empathy in, you know, the development of software systems? And I was quite lucky just a couple of weeks ago to have Daniela Damien come to UL. And her whole lab is set up to look at the concept of empathy. But what she did, of course, was tied it to quite strong social problems. You know, what happens to people that are homeless? and people are homeless for a whole set of different reasons. And how do you develop those kind of software systems where you're actually building trust amongst the community? So I think that for me, we need to think about teaching practice needs to be related to things like understanding values, things like understanding ethics, things like understanding professional development. And so there's a broader context to just the technical dimension of the field of software engineering. You don't need to clap. These are your views. This is just my summary of your view, right? Okay? Do you want to add something?
Yeah, we actually thought of something here. In addition to what you mentioned, we actually thought of diversity in software engineering, because the African context is one that is so diverse in our own context now. So we have people from different cultures, people with different spiritual beliefs, and we have people who actually live with disabilities. As I think, as part of software engineering during design, we also, when we are teaching software engineering, we need to take into context these diversities in our development. Thank you.
That was a point well made.
I want to make an addition to what you said about empathy. So there's something that we also need to consider in terms of the teaching practice in software engineering. So the people developers, the writing the code, they have to try to tailor the solutions to our local context. So let's say I'm trying to build something, I should tailor it to people around me, not looking at the global perspective, because what might work in other countries might not work here in Nigeria. So we should try to work on tailored solutions. Thank you.
Thank you. I think there was a comment from the back.
Yes. Yeah. I just want to add to this empathy perspective. I think we should teach students to recognize things that are not sustainable. We should teach them to recognize things that are not sustainable. You know, if they should be able to identify, there should be a way they can say, oh, this thing, we can't sustain this thing. There should be a better way to do it. So we should be able to pass that kind of skills to them. You know, it's a kind of empathy. When you start seeing waste, excesses, and things like that, you should know, oh, this is not sustainable. Maybe you can find a sustainable solution to this. Yeah. Thank you. Yes.
Okay. So I have like a slightly different view. So when we are looking to build a software, I think we can focus on the technical parts, especially in terms of social sustainability. We can focus on the technical parts of the software to make sure that what we are actually building works. Then we can now add layers of regulations on the data that is being exchanged, because it's the data that is actually going to, if I'm passing a slaw at somebody, I'm sending data. You understand? We can now pass regulations, like maybe what TikTok is doing, censoring. You understand? So I cannot say I want to build something now, then I'll be thinking of one particular. It's not going to, it might not work, it might not be sustainable, because at the end of the day, whatever we are building is for money. You understand? It's for the financial benefits. So making sure that what we are building actually works, so that we can write efficient codes. Because if we say, oh, let us build something that will not take this, will not take that, will not take that, we end up writing inefficient codes, and we are now fighting our first one, which we spoke about. Then after building what works, we can now include artificial intelligence on how data is being moved around. So yeah, that's my point.
Interesting perspective. Thank you. Right, so we need to move on to the next one, and the next topic deals with the individual dimension. So this is a scaling thing. We started wide with the environment. We're now thinking about society, and we're now thinking about that. What does that mean for you individually? What are the key concerns that you need to think about? So how potentially might you benefit from something, or how might you not benefit from it, depending on the type of teaching practice? And again, keeping that very much with a view on software engineering education and in the context of an African view. Yep. Okay, so we'll give you, again, another 5 minutes to think about how is this different, okay, from the scaling down to the individual. Okay, let's see if we can pull some of the ideas together. Is there anyone who would like to make an observation about how we map teaching practices to individual dimensions of sustainability? We're going to have to get Birgit to do her acro thing. We should have taught that to them in the first instance, I think. You're bringing back to attention. Yeah. Well, I'm going to make quite an interesting observation. And the word soft skills appears in one of the feedback that we have here, the suggestions. I have quite a view on soft skills in the fact that they're not soft at all. They're actually really hard. I can teach anyone to program, but I can't teach some of the soft skills about what it means to be a good communicator, or what it means to collaborate with people, or how to work in a team, or how to, you know, there's certain things that these are actually really, really difficult things to do. And I think software engineering potentially teaches them implicitly, but not explicitly. So for me, it would really about how do we explicitly integrate the hard skills into everything that a student does. That would be the kind of the challenge for me as an educator, because most big companies, at least, there was a survey done many years ago in the UK, and they said, what do you require from graduates? And none of it was technical skills. Not a single thing was mentioned about technical skills. It was all, are you a team player? Are you a good communicator? Are you a good problem solver? Those are kind of the real things. And I think potentially that comes back into, you know, how do we create the environment for students to do innovative things? How do we teach them the fundamental skills? How do we map the theory to the actual practice? How do we give them real world contextual problems that they can develop empathy for? It's very difficult to develop empathy for things that you have some obscure relationship to. Yeah, and I think, you know, Birgit mentioned this earlier in her keynote. The concept of perceptual distance. So the further away you are from a problem, the less you care about it. But when it's very localized, you know, and I've seen this come through in all the things that you have been suggesting. There's a local contextualization to all of it. Okay, so that's kind of my overview. Would someone like to add anything to that?
Okay, so like I was discussing with my team, I'm talking from the Nigerian perspective now. One of the main issue we have is a cultural issue. When I mean culture, I don't mean ethnic group. I mean a culture that promotes a certain type of excellence. Okay? So imagine someone that is studying computer science now. For you to be studying computer science, the basic thoughts of anybody entering to study computer science is they want to learn how to code so that they can go and work for Facebook. They want to learn how to code so that they can go and work for Google. They want to learn how to code so that they can go and work for Amazon. But is that the reason why there is a course called computer science? So in that case, they miss the basic concepts, which is the core of computing. Even without coding, looking at the problem, analyzing the problem and computing it, even without typing. You understand? So we miss that. And with that, and on the other hand too, we now also lose like a sense of responsibility towards problem solving, which is actually what makes us computer science students. So the moment we miss the basics of what we are here to do, I mean, there's no other basic that we're not going to miss. So yeah, that's my point.
We have Mercy online here who would like to speak. Let's see if we can make this work.
Hi, everyone.
Hi,
I
Mercy.
believe I'm audible. Okay.
Yes, you have the room. We can hear you and we can see you.
Oh, cool. Thank you very much. So I think I was just going to pick up from what the last speaker said, because I remember when I started working, a popular phrase that I came across was, "What problem are you solving?" You know, back in school, there's this excitement of learning new technology or this new language, that new language, but we didn't really get the understanding that we're trying to solve a problem or you're trying to make the world a better place, you know. So I think that with software engineering, definitely it involves a lot of problem solving and brainstorming, and it's kind of strengthens students' critical thinking and creativity over time, you know, without even them realizing it. And you know, we kind of are closer to the users of our solutions, and it will require a more human-centered mindset. So I think in it's by teaching software engineering in a way that emphasizes in the individual aspect right now, it should emphasize like real world impact and then the user value. We are not just building technical skills. We're also nurturing, you know, individuals to be more thoughtful, to be more aware socially, and that way we'll be able to provide solutions that are more, you know, in line with what we are facing here in the continent, you know, and all of that. So thank you.
Thank you very much. Any other comments or observations? Okay. So we're almost at the end. We have two left. Okay, so this one is about the economic perspective. How do we map that to this particular dimension? How do we map teaching practice to get to understand economics? And again, you know, this kind of emphasizes the fact that software engineering is not just about technical skills. You know, we've heard about innovation and about, you know, incentives around money. Let's think about, you know, how we might consider some of this stuff. Okay. Again, I'll give you 5 minutes. We'll come back for comments and then we'll move on to the next one. Okay, again, in the interest of time, let's see if we can draw a line under this particular topic and pull some of the threads together. So one of the observations I have there, again, is that software engineering is just not about the technical things. How do you build entrepreneurial skills into the curriculum? So you have kind of a nice pipeline, which, you know, leads to job creation, employability, financial security. So I think those are quite interesting things as well for you to think about. There was something there that, let me just have a look back at the comments. Yeah, that was my main observation, was really about you know, to come back to one of the comments from this particular group, they talked about creating the environment. And that means that you need to think about the overall structure of the organization in which these programs potentially could be delivered. So I think that's quite an interesting thing for us to think about. Another point is the localization. So again, that comes back to context. If you give students solid contextual problems to think about, then you've suddenly got the localization bit there. Yeah. And overall, that it's not just about core technical skills. It's about, I mean, I often think that software engineering is not really about the technical stuff. And as a software engineer, if you want to wear that badge, software engineer, it's not just about writing code. It's about a more holistic overview of the entire software system that you're building. And that requires a whole set of things that are not just technical. There are a whole set of other things around that. Any other observations from the groups themselves?
Good afternoon, everybody. So I'm here in our group. We mentioned about the general orientation of entrepreneurs here in Africa or Nigeria per se. About the general, orientation is just to go into the business as a means of earning money because of the economic situation of the country. But I think we need to put more focus on creating value and solving actual problems. You know, there are so many problems here existing in Lagos alone and Nigeria in general. We have traffic, pollution, and so many issues like that. So if we put in effort into creating solutions to those problems, we'll be forced to, go into that solution and pay for it if there's need be. And that way, you are making money for yourself, solving problem, and everybody is happy with it. Then we also mentioned something about getting knowledge about what's going on around the world. Here in Africa, there's this general saying that the Europeans and the Americans are way ahead of us in terms of technological advancements. So when we tap in knowledge from what's going on in China, US, and many other advanced countries and bring in the knowledge to our software engineers here, there are so many solutions to our problems that have already been solved in China way long ago. So with that knowledge, our software engineers can actually develop solutions to our problem and make money from it. You are creating value, problems being solved, and money being made by everybody. Yeah, that's it.
Okay, my name is Samuel, because I've not said my name since. So my name is Samuel, and our point from the team here is that we need to create solutions. We need to create products that are, I would say, that are using a human-centric approach. Like, you are trying to build something, you are not building it for yourself, you are building it for people. So you need to put them into consideration properly when coming up with solutions. So we believe that if that is being done, we are going to come up with solutions that will meet user needs, and not just meeting user needs to a very great extent. So by that, we are coming up with systems that deliver a lasting value. That's for that. And as for cost efficiency, we believe that developers should come up with solutions that, even when they are digitalized, they are also fully automated. Like, for instance, now let's say I'm not in Nigeria, I'm in the diaspora, let's say I'm in UK, and I need my transcripts to be sent to the university where I am. You know, currently we still get calls from people outside the country that, can you help me get my transcript? Can you help me do this? But we believe that building solutions that are fully automated
is going to save cost and efficiency. So this should be put in consideration when we are trying to come up with solutions for problems. Thank you.
Just to add to what my colleague said, so I also think we should also caution students about the dangers of over engineering applications. So you should just keep applications simple, just the features you need. Because adding extra features which are not needed, it's more cost to the individuals or to the company, or as the case may be. That was my own point.
Okay, I want to talk about adding incentive. In Nigeria, we like money. And whenever you have a model, you want to make it sustainable. It's very good for you to put a rewarding system to it. Incentives are like key drivers for sustainability. You know, when you have maybe a student and you tell your students, once you want to start using green software engineering, and immediately you just download or install, you get an airtime. You see people rushing down there. So it's a good way to have a widespread of the usage of the software, and it's okay for sustainability. Then I want us to also look at, as a person, I don't like the copycat syndrome. I noticed that maybe as an engineer, a lot of our problems is because we copy you. We copy your problems, and those problems don't give us our solution. So I think we should have local problems and we should have local solution. I don't need to copy your problem with your models, your functionality to solve my problem. I am Nigeria. The way I operate is different. The way I think is different. The way I reason is different. So just look at it. I'm coming to work. I take a bus. I struggle to take a bus. In United States, you don't struggle. We jump to take a bus. So those are our problems. So let us have good solutions to our problem. Thank you.
I think it was the gentleman here in the morning. He said something about cost benefit analysis, right? And I didn't want to interrupt the discussion, but one of the things that you need to think about is the relationship between the technical design, and some of the observations here are very true about that, and the implications for the cost of it. There's a very good book called Clean Architecture by Bob Martin, and in it he presents a case study as an argument for having software architecture in the software system. Most software systems are built from a code first principle. Let's write some code and the system will emerge. And all systems kind of emerge from that, right? But there is no cost benefit to that type of approach in software engineering. And so what I always try and do with my own students to get them to think, and the word decision, I think maybe came up in the last set of slides, was how to evaluate decisions that you're going to make. And that ultimately ties back to the economic thing. Is it an economically good decision that you're going to make? So in the case study, he says, or he shows some graphs. And in the two graphs are productivity and salary, which are the interesting ones. In release 1, high productivity, low salary. By release 8, it was completely inverted. No productivity and very high salary bill. So then in essence, there was no cost benefit for that software system because come back to another observation, is that most of the cost of a software system happens after it's been built. 70% as a ballpark figure of the cost of that is simply in maintenance. And my argument is if you have no architecture, then those costs are astronomical. Yeah. Okay. Right, we're finally on to the last slide, okay? So this is really drilling down into the technical bits, okay? So as software engineering educators, as software engineering practitioners, as software engineering students, what potentially are the key technical things that we would really need to understand in order to address any of those other levels that we've spoken about? So again, I'll give you about 5 minutes and see if we can get this session wrapped up by 3. And I think that would be a good end to the session. Okay. So again, think about this. What are the technical things that you really have to factor in here?
Eh? Oh. Ṣé dọ́là wà ní? Ṣé ẹ pín dọ́là ní? Púpọ̀ dọ́là ní bẹ́ẹ̀. Ọ̀jọ̀gbọ́n lẹ jókòó tì yẹn. Ọ̀jọ̀gbọ́n lẹ jókòó tì yẹn. Ah, ah. Exam ṣe ń lọ lọ́wọ́. Àmọ́ a ṣì ń ṣe exam lọ́wọ́. A ṣe exam lọ́wọ́. Ọdún bẹ̀rẹ̀ election máa tó next week àti ṣe mark. A ṣe mark gan lọ́wọ́.
Yeah, let's see if we can bring this to a close for the this particular session. So oddly enough, there's less input into the technical bit, which is quite surprising. So the two comments that are there is about sunsetting software, which really means that we need to think more broadly as software engineers. How do you bring something from inception to end of life? Yep, and the software engineering process really should kind of emphasize that. But then that's kind of a challenge about, you know, how do we integrate that kind of thinking into our software development programs? Something that I'm quite interested in is, of course, techniques for maintaining software in a sustainable manner. So for me, one of the things that is missing potentially from software engineering programs is obviously there's sometimes it's there, but it's not explicit. And it goes back to the basic definition of what is software engineering. And if you were to look at the ISO definition of what that is, it has a very interesting word in there, and that is the word quantification. And we often think about quantification in very kind of simplistic ways. We think it's about writing unit tests to make sure some kind of function works. But actually, that's more than about getting us to try and understand how do we measure something like maintainability? And what are the interesting key metrics and measurements for that? And how do we integrate this into, you know, potentially any kind of software development lifecycle pipeline? So again, that's about, you know, what become the core things. And I would always argue that we need to think about how we measure stuff, because it comes back to a core topic that Birgit and I both teach. And the thing that I always emphasize in that no, it's come back. It's come back to life. The key thing about requirements is that they all have to be testable. And that includes that dreadful word, non-functional requirement. Well, which most students go, non-functional requirements? I have no idea what that means, right? So we need to think about how we really kind of sort of integrate this in. And, you know, there's sometimes good arguments for siloing and isolating things. So I just think about the requirements. I really won't think about the testing of those things. But really, should those things be taught together as a way of thinking about testability? If you've ever read the book by Fred Brooks on the Mythical Man Month, he presents quite an interesting argument that only 1/6 of a software engineering project, regardless of its lifetime, should be spent on coding. The rest of it should be on understanding and modeling the requirements and testing whether those things have been met. What else has come through? We've talked about this idea of having interesting case studies, localization of case studies. So, you know, this idea of realistic, authentic types of problems is really important for students, I think. Birgit and, well, the group presented a paper at ICSE 2017. And one of the comments from the audience was, how do we ensure that we are authentic educators? If you go into academia, do you always stay in academia? What is your integration with industry and industry problems? And I think that's quite important. I often talk about Fisher-Price education. Fisher-Price is a toy store in the UK, and we give students toy examples to deal with that are in no way related to reality. And therefore, we have to give them difficult things to think about. And I can't remember, it was the observation that you made. We need to think about, you know, how we teach students through but making mistakes. And how do we break that thinking in students where there is not always an ideal solution to the problem? It's messy. So my software engineering students, they want the answer. But there is no the answer. There are simply many different kind of solutions to the same problem. And you can arrive at the same solution, but different pathways. And so thankfully, I have the first years. And so, you know, the key thing that I emphasize, even when I'm teaching relational databases, which I was doing up until recently, is that you're really dealing with uncertainty on a day-to-day basis, an hour-by-hour basis. And the sooner that you embrace uncertainty, the happier you will be, right? Because they want to move to the state of away from that certainty. But you're never really in a certain position. What else do we have up here? Any make some observations?
Thank you. I'm Priscilla. So here we discussed about data structure and algorithm as one of the backbone of programming. And we were looking at it like the school system, in a way, is not so doing well in that angle, because an average student, they are not well equipped with what DSA is all about. You know, for example, I had a brother back then, and he was very good in programming. So like after 10 or 12 years then, he applied for a Turing test, and he told me, he said, see, I failed this. I said, wow, but you could. He said, no, which is his knowledge of algorithm was so shallow. So he told me that don't miss it in this aspect. If you want to be a good programmer, ensure that your DSA knowledge is very, very sound. Actually, it requires logical thinking. It's not for the lazy mind. So an average student, we always want to run away from that. And you know, the school system also is not really encouraging. The system is not encouraging. So I think that was our discussion. Thank you.
So in addition to what you just said is that since we know that data structure and algorithm is very key, so the educators should find a better way, a better teaching practice method to pass this knowledge across to the students. Thank you.
We spoke about building software solutions that gives room for user feedback, because at the end of the day, software products are majorly built for the users to make use of. So when we build software solutions where we can actually get feedback from the users to know the aspects where improvements needs to be made, it will improve the lifespan of that software solution, and it makes it more durable and adaptable. Thank you.
Yeah, in our group, we discussed about the components
if you are building software, you don't need to start from scratch. Then you can look at components, existing components that are efficient in time complexity. Because as you reduce your time complexity, then you are maintaining sustainability. So it is the goal, we can pass it to the students or consultants, whatever, that they should look at components that are efficient in computation. You know, as you have efficient, put all those components you need together, so that you can reduce the computational power of the system. Then you are also reducing energy, task on that system, and you are making the system sustainable. That's what we discussed here.
Yeah, thank you all. From what he said, and before he even got to that, a nagging question kept coming to mind. When you're developing a software solution or program or application, we are always told not to go all the way trying to, what's the word now? Invent the wheel. That's sourcing what is already available. Thank you for that. Where did the issue of intellectual property come in here? Because you use somebody's code or a program that is existing. What are the conflicts that can arise? It will be very interesting to see how that is addressed. Thank you.
Thank you very much. I have been teaching software for close to 30 years. And what I recognized with my students is that there's no technical dimension to the education. And the duration of their curriculum is too short for that to be accommodated. So in 2016, I led my department in developing a 5-year curriculum in computer science. But unfortunately, the Nigeria University Commission and the people that are in charge of curriculum development, they insisted on a 4-year curriculum now. Because what we did in that curriculum, because I chaired it, I put it together, was that from each semester, we took on we went for very simple programming skills. And each semester, we introduced a software lab, not a course, a lab. A lab where you spend, I think, 8 hours or so in a week. We had a lab, and every semester we introduced software with increased complexity over a 9-year semester program. So that technical dimension to sustainability, a large majority of African students, when they enter the university, don't have that technical skills. So by the time they graduate, the skill is still missing. It's still missing. So there's a lot of advocacy in this particular aspect. And like you mentioned, when they are teaching software engineering, they should always teach it from the perspective of solving problems, real-life problems. They should take it from solving real-life problems, not, just go and do something that can count this. No, they should always give. Then they should also take a team approach, like you are working together all the time, from the very beginning to. Then there's also an aspect that, for what she said, I don't know her name. She said something about our brother who has been coding. I have a daughter who graduated from system engineering. She's a Texas, whatever, and she has been coding for 3 or 4 years. But she codes by looking at examples. So when I talk about algorithms, she doesn't know. When I talk about data structures, she doesn't know. So these are the things, these are the very basic things and fundamental things that should be taught not as courses, but as software laboratories. You know, so unfortunately, they scrapped my curriculum, which is one of the best curriculums in Nigeria.
I agree. I agree. I agree. I agree. I agree. Yeah. I agree. I agree. I agree. Okay, yeah. Okay. So I think Dr. Fashino has said most of what I wanted to say, but I wanted to give like a very small example. Okay, so for example, some people write they build websites. So they understand, they write HTML, CSS, and JavaScript. Now, JavaScript has a concept called document object manipulation. And most people that understand JavaScript do not understand what's the document. They just know how to call the functions based on examples. So when you look at the concept, basically expressing your HTML as a tree for efficiency, so that the JavaScript is like a thread that goes and says, okay, you want a paragraph that has a class of this, and you want to change this to this. So basically, it starts from the roots of the tree and goes down. Now, they used a basic concept called tree, okay? And now, I'm a computer science student in my final year. When it's time to teach, when it's time for students to learn about tree and all that, it's not relatable. We can't relate to what exactly it is. If not that, okay, I've gone an extra mile to see, okay, is this what's the document object manipulation is? I'm sure there are so many people that write JavaScript here that cannot explain the document object manipulation. And now, the people at Facebook, although they did so much engineering, they went a step further to build React. React still takes some of those basic concepts. That's why you hear things like fiber, reconciliation, all those things where they say, okay, how do we optimize the cleaning and recoloring of the screen? It's basic DOM manipulation concept. If we do not know it, then we'll fall back to Googling example and pasting it. When the actual solution is a concept. So conceptually, you see people running away from concurrency class when you cannot build a big system without concurrency. You see people running away from, okay, I think they don't even know that maybe what they do is sequential programming and all that. They do not understand. So if there is a better way for us to say, okay, maybe a way to make what we are learning relatable, then we can now say, okay, if a child is crying, give him sweet, he will stop crying. You understand? Because we understand the problem. We understand the complexity of what we are dealing with. We're not just learning abstractly. Yeah, so that's my point.
Okay, I want to speak on as a faculty. Teaching computer sciences, particularly software engineering, I feel that there are practices that we can use to enhance students' technical know-how. So I was teaching this course, Software Workshop 2, Year 2 course, and I infused some learning practices that I've learned in the course few months. So I wanted to see how is this practice going to impact how the students study. And I made them know this is the first time I'm teaching this course, but these are my expectations. Since it's a software course, let's see, at the end of the course, let's look around our vicinity. Let's identify the problems that we have and see what we can do with the knowledge, basic knowledge from this course. And I'm glad to tell you that we have gotten 20 different problems. They were able to identify year 2, 20 problems around them. So I feel as instructors, we can also go a step further. We can go a step further in making these courses enjoyable, kind of. So if you know the courses that students like run away from, what is it? How is it that you can make it, you can sell it to them? Because the students they have this creativity in them, and they know a lot. They know a lot. So that's my submission. So let's just guide them, and we'll be amazed with the problems they can solve. Thank you.
Just to add to what Dr. Fashional said, as regards our curriculum. So I studied applied physics in my undergraduate, but I have a lot of friends in computer science, and I always heard about Dr. Fashional. So this is the first time I'll be seeing you, sir. So, like, just to relate it to my own study too as well, I feel our curriculum, studying applied physics electronics, like the 4 years is not enough because we don't have a lot of technical background, a lot of things we do. Just imagine our COS is just for 3 months. And during the 3 months, I was working with University of Lagos networking, and that was the first time I could apply LISA to a fiber. And I was like, so this is the LISA that you are just telling us is not 6. I don't even know how it is. I don't even know what it is. But, you know, when I came across LISA, I sent light from one end. I went to the other end to check. I was like, so we need, like what you said, the curriculum. And sir, I don't know if you can push it further again for your curriculum to be accepted nationwide. Thank you, sir.
Okay, I think that some very interesting observations that deal with some fundamental problems in how we teach things, to what is the environment, to a more holistic view of how we understand the concept of software engineering. So I think that kind of lays the foundation for interesting discussions moving forward. It is almost dinner time, and we've not had lunch. I'm not sure what in between lunch and dinner is called. Okay. Yeah. Okay. Right. So we're going to take a break. I have no idea where we are in the schedule in terms of timing, but thank you for your contributions for this session. Battery will stand by, so to back come on, then I change it. They won't go at me.
Thank you very much, Dr. Rufai. Thank you very much. We'll be creating a faculty of computing and informatics in July. The University of Lagos will be creating a faculty of computing and informatics in July. They'll be unbundling the faculty of science and creating 3 faculties. And one of the faculties one of the faculties they'll be creating is Faculty of Computing and Informatics. And that faculty is going to be created from the current Department of Computer Sciences. And they're going to have, for starters, they're going to have 3 programs. But over time, they're going to have 6 to 7 programs, departments. So the 3 departments that are going to start right away in July are Department of Computer Science, Department of Software Engineering and Cybersecurity, and Department of Intelligence Systems and Robotics. These are the 3 departments that are going to take off. So when Dr. Rufai said they are having a summer school in software engineering, I automatically felt that this program has a lot of relevance to the unbundling of the Faculty of Science, because then it's just going to be a summer school for the Department of Software Engineering and Cybersecurity. Exactly. So it's just coming at the right time. It's a fantastic program. But my wish is that we're able to create something out of this, something that is enduring and sustainable, and has a lot of relevance in the development of our students. Now, and that brings me to the topic that you started. What is missing? What is wrong with the way we teach software engineering today in computer science departments in Nigeria, not even in University of Lagos? What is wrong with the way we teach computer science? I was in LASU on sabbatical in 2016. I was there for 1 year. And it's the same problem we have in University of Lagos that we have in LASU, Lagos State University. We have students that run a 4-year program and cannot write a single line of code. It's not like that for all of them. In a class of 60 or 80, around 10% are very good programmers. Before they leave school, they've already picked up job. But the large number of them are struggling students. They're struggling. And that is what I observed before I went for sabbatical. And by 2016, when I was going on sabbatical, I dropped a 5-year curriculum on computer science. And we're about adopting that last year. It took us a long time to adopt it. We were about adopting that last year, or year before the last, when they brought in CC Mass. And as far as I'm concerned, they destroyed the curriculum of computer science in Nigerian universities, because that CC Mass is below standard. It's below standard. What went into that 2016 curriculum, for me, was about 30 years of teaching experience. I'd already done 2 curriculum for the Department of Computer Science. I'd done the curriculum for Masters of Information Technology, and I also did a curriculum on intelligent systems and robotics at the master's level, but it was not adopted. It was just kept on the shelf. And of course, this, because I did a fellowship on curriculum development in 2001, so I was equipped with all the skills to do curriculum development. So now that brings me to the present situation. What is wrong with the way we teach computer science that 80% of our graduates cannot write code? And that's what I'm going to try and discuss now. How can we solve that problem? What is wrong here? And incidentally, my son is still in secondary school. He was on the internet like 4 days ago. He said, "Dad, is it true that barely 10% of graduates from computer science worldwide can program?" And I said, yes, it's true. So it's not a Nigerian problem. It's not a Nigerian problem, it's global. So what is wrong with the curriculum in the education that makes programming so difficult to pass to our students while they're in the university? I remember there was a student who did a project with me, in I think it was 2018. She couldn't code. But then she graduated and she wanted to go to Canada. So she had to go and learn how to code. And she could code. So it wasn't a problem. It was the problem of the system she passed through. She was able to code. She was already earning money as a programmer. Then she traveled and got married in Canada as a programmer. But throughout her career, she just found coding difficult. She just couldn't write a line of. She couldn't code. So what is it? What is missing? What mistake are we making as educators that we cannot impact on our students while they are still in school? So we like to look at that. If I have, maybe we start with computer science students before the educators move in and start offering solutions and suggestions. Are there computer science students here? Yeah, please, can you put up your hand? Yes. Are you computer science? Oh, you are just computer science. Are you computer science? Okay. Any other computer science students here? Computer science? Then which department here? University of Lagos or Lagos State University? Okay, last one. So which are you? Yaba Tech, you? University of Lagos. Okay, so we have 3 computer science students here. 3 different institutions. Which programs are you running? System engineering. Also, you qualify? Yes. You do programming extensively. So I will just add it to them. Then you want to know programming or you know it already? You do programming too? Okay, all right, okay. So are you? Oh, okay, you want to learn how to write code. Oh, that's why you are joining the system engineering. Okay, as an entrepreneur. That's why you are joining them. Okay, that's lovely. That's very good. Okay, so let's start with are you a good programmer? Okay. So did you have that initial problem of coding? And if you did, how did you solve it? Thank you very much.
Good evening, everyone. My name is Joel, and firstly, before I got into school, if I get admission to school, I already have basic knowledge on programming languages, Python, JavaScript. So, but while I was in school, because I'm in school, and what I noticed with most of my classmates is that they find it very hard to learn programming due to the teaching method, because most of the lecturers don't even code. They just come to the board and start reading for you. Like you're learning C programming, for an instance now. They will just start reading you C programming and they'll tell you this is the code they're writing on the board, instead of using practical example on writing code with system and so on and so forth. So the way I see this aspect can actually be solved is that there should be proper training that should be given to the teachers on or facilities should be available to actually make these teachers do the practical explanation of that particular coding exercise, and also give illustration, real life example to help students assimilate more better. Thank you very much, sir.
So you tell us, tell us your background as a programmer, and do you currently have any problem with coding, and how do you solve it, or are you still having that problem?
Okay, so good afternoon, everyone. My name is Isiak. So the first issue I had as a computer science student was I was absolutely not knowledgeable about what computer science was before I got into it. So I think we should inculcate into the elementary school curriculum basic knowledge of programming and software development. So while in secondary school, I was very good with use of computer for basic Microsoft Word, Excel, and all those things. So my computer teachers used to hype me up, go to school and do computer science and all this. So in Baek, I was one helping the other students to do their computer practical. So I was really hyped up to like go into computer science when it was absolutely totally different from what I knew about. So when I got to 200 level, many of my friends were talking about Python, Java, and I was looking really lost because I haven't heard about these things before. So it took me a long time for me to actually, adapt into the system. So I was then the teaching practice wasn't helping also because I remember then, whenever we were given tasks to solve, I was struggling to write it on the laptop. But when we get to the test, they tell us to write the codes on paper. I can't even write well on the code editor yet. They are telling me to now write on paper. So it really gives me a lot of issues. But I was, with the help of my friends and some lecturers that were really helpful, I was able to adapt a bit. Then when I went for IT for CS last year, luckily I got I got a placement at an IT solutions company, and they didn't mind my basic knowledge of programming and software development. They were able to groom me well. So the whole 6 months of CWS really helped a lot to bring out my interest in software development. So now I'm doing very well with software development in terms of web development with JavaScript and React, and I'm really hopeful to work well on that. So that's it.
System engineering. Good afternoon, everyone. So I think I can relate to the story very well because I have a similar experience. And I think most Nigerian students have the same. But when I was younger, I have this I usually love to fix things naturally, just like so I just feel okay, there's something there, creative, being creative with fixing stuff, and also started to go into system engineering. But then coming to system engineering, we say it's a different ball game. So it's always like that, I think. So that was the experience for me. So I had to start brushing up with same thing too, Python and all. So I'm currently in 300 level.
300 level.
Yes. Yes.
Can you tell us, before you hand over, can you tell us the difference between system engineering and computer science?
That's
From your point of view.
okay. From my own point of view,
Can't answer that
it's
question.
difficult.
Okay.
It's difficult.
So can you give us your background and
Good everyone.
that difficult with programming and
Actually-
where you are now?
Actually, before I went to school, I started learning some command CMD, how to use CMD very well, because they told me that for me to enter programming, I need to learn how to use the command line. So I was learning command line and also doing some programming stuff. So I went into learning C++. But when I got into school, they were like, Python is good. So it's Python I use for robotics, not C++. But my findings, when I made my findings, they told me in US, they use C++ for their robots.
Python is interpreted.
Yeah, that is yes, but now I'm an edge now. I've gone learn Python, but my C++ knowledge is still intact.
So do you have any problem in school? Is it because you knew programming before you went to school? You came to school that you didn't have any problem?
I really have problem, but I'm still struggling with the data structures and algorithm. Yes, because those kind of parts need to apply logical thinking.
So there's a gentleman over there. Can you give us your, can you introduce us, can you introduce yourself to us and give us a background?
My name is Sulaimon. I'm a computer student, science student of Lagos State University. So I think the problem is the time. Yes. Last semester, I did a course on Java. The time given for us was very short. The lecturer come to class, just to talk on the basic and give us projects to do. So for students that did not really have more interest in it, it will be difficult for them to cope with the course.
How are you coping now?
Before I gain admission into the school, so I went to a tech school for 3 months.
Okay, that's what you picked up.
Yes.
So that's what helped you.
That was what helped me.
Okay, I will give my own background as a student. Then you now know how. Okay, are you programming? Oh, not to give us.
Yeah, thank you very much. I will relate with some of what these gentlemen say. As now I'm a postgraduate student and by God's grace, completed my master's, the same systems engineering. And this is what I observed. When I started at my 200 level, we start a course called the programming languages. It's also there to year 3. At my year 3 that I actually cut my teeth into what programming is. Because then, thank goodness, we had the gift of a Professor Fakinlede who came to give us that then. But before that, there's something I can relate to at my 200 level. That's just like they say, if there's any change in the platform or the lecturer taking that course, it affects everything. As a summary, let me say this. It's as if when we came, the way they presented .NET, C# to us, you think it is the next best thing that will happen to the programming world. Now, today, nobody is thinking about C#. Everybody is running after Python. And I'm wondering, where are we? I still have it running on my system somewhere. And I don't know. So my friend, are you doing any C# now? I hope you can hear that. So this is what is going on. So there's one of the problems. But I find out that, okay, beside that, it was when I went for my IT that all of a sudden you understand, I saw the connection among those programming languages. It was, I happened to work or had my COS experience in a company that is into app development. They develop app, and I was introduced there to Java. Clearly, from my own perspective, maybe anybody that understands the two programming language may agree or disagree. C# is a ripoff from Java. That is what I observe. I can say that from my own experience in the little coding I did. We developed an app then.
But
So
there's nothing wrong with that.
yeah. So, but what is there is, can we have a succinct platform where new learners can stay onto and cut their teeth in programming before they can now develop to any platform they wish? Thank you very much.
Thank you. Well, hold on, let me. I need a program. It's not a program.
So what I want to say is going to really add to the discussion. So like I said earlier, I studied applied physics, but a lot of my friends are in computer science. And aside that, like 2 of your recent first class students, if you know them, Agbola, Fuad, and Shion Oluwafemi, now my friends. So this is what I want to say. When you inspired them in your own, I started a startup, like I was building edtech solutions. So I discovered that these 2 of my guys that are on first class, I finished with first class, and they are currently working for company. So when we don't stood out from their peers, so that's what I want to chip in, because you need to help what you are working on. So when I came up with an idea of building a CBT software for students when the underlevel exams turned to computer-based tests. So Shion was helping me. I was not paying him, but we're using that to learn when we did VB in year 1, which was a general one for everybody. We went on building some other online platform. So Shion was working on stores. He don't say it today that it was my small project that really helped him in his programming line. So what I'm trying to say is that I think other people that might not be insurance standard in terms of programming and code because they don't have enough practical and works to do them. So I think now that they are trying to, they should make sure that there's enough and more practical for them to do. So beyond just the writing paper on code, solving real life problems and providing solutions. Thank you. I want to talk on behalf of students as a faculty member that have been taking students in programming over the years. One thing I notice is fear. We have this psychological fear for programming. And I always tell them, programming is not the problem. The problem is the analysis of the problem you need to solve. You can analyze your problem in your head. You can say, okay, I will do this, I will do this, I will do this, I will do this, then I will divide by this. You have eventually solved that problem. So you are able to, and I find out that most students cannot do analysis of the problem they want to solve. If you cannot analyze the problem you want to solve, you cannot do anything. You just be looking at this. You cannot code is just about 20% about that problem. You know the analysis. You can use any programming language. Those ones are available. Put the syntax, and keywords, the syntax around the keyword, and use it to construct that thought, that analysis you have done in the book. You have to be working. So most problem of a student is one, fear, and the analysis, mathematical analysis, whatever of analysis that's beyond the problem they want to solve. First of all, let's address that area of fear and analysis. Look at one that you can actually do. So that's
Well, I will, Dr. Rufai, do you have any comments on? Oh, you want to comment? Okay, all right. Okay.
Thank you, sir.
Yes.
So I wanted to stay in the gap my students, for one of our students. And I think I also want to discuss about system engineering and computer science. And I can see that the confusion is really, really great. And is really affecting it when students are also coming in. So irrespective that we have some overlapping areas, there are some differences among us. So system engineering is more like a multidisciplinary area that integrates different systems and works with their life cycle to perform better. Why computer science really deals with majorly is like a specific area in terms of algorithms, data structure, and the rest. Even their methodology also differs in the sense that we do more of system thinking, we do more of system verification, validation, and the rest. While computer science, really deal on software development, computational time, and the rest. So sometimes we have some overlapping areas. Because we are, is like there's a lot of integration among different fields. So you can say system engineering dwelling well in robotics, in AI, in computer, in health systems. What we are concerned about is the methodology so that we can have a working system. Thank you.
Dr. Kimboro, that's our faculty, Department of Computer Sciences.
Thank you, sir. I just want to contribute to what the students have been saying as regards program development. And I want to classify program development into two phases when it comes to teaching. One is the lab, and second is the teaching itself, that lecturer. When this boy was saying that lecturer doesn't know code, don't be surprised. Lecturer, you think he doesn't know code. He knows the code very well. But one thing is that when we are passing information across during teaching, It's different from when you go to the lab, you go and actually teach what I've been taught. In that, well, we will give you dry run on it in the class. We're supposed to go to the lab, to go and meet the lab person to put you through, and if there are any syntax error or the likes, you plug it and run it and let it run. Then, but if the person in the lab is not knowledgeable enough, that's where the gap is. Because I remember when I was in Wales, we employed a programmer and we employed a database administrator. And all our students in that set, they can code. And I could remember that when it comes to programming contest in Nigeria, Boys University was at the forefront then. Why? Because we have them on the ground. Students go to the lab on themselves with their laptop, and those people, because they are already programmers, they develop apps so they can put the student through. We have given them the knowledge already. They then left to them to create time and go and meet those people and put them through. But if that one is lacking, then the gap will always be there. So don't say, I teach you. I know what I'm doing. I'm doing my research. They will not use the class to assess me. It's my paper. It's my research. So my attention is on my research. If you come and see the code I'm writing for my simulation likes, you will run away. So don't say, I don't know what I'm doing. But not me. I'm not saying it generally.
So I think we have a number of.
Yes. Yes, thank you very much. I think the problem with software engineering education in Africa generally has to do with low resource as well. If you are teaching a course like software design and architecture, you are expected to experiment on different types of systems. Even some, you will need some small devices like a Raspberry Pi and so on. But due to funding and whatever, you see that most lecturers will gloss over the concept and test the student theoretically, and they go and that is it. So it deprives them of the practical knowledge. Another thing is our teaching methodology too. We don't have to blame the system itself. Our teaching methodology is kind of focused on what you have on the course content. You want to follow the course content. This is the whatever. But we are not approaching it from the problem-solving point of view, where students are made. We can make it a kind of they become apprentice. So it's like an apprentice. You are a carpenter. You become an apprentice. You follow through the practical nature of, the step of each of the process. But what we teach them is, we throw a toy example, for instance. We teach them that. We now expect them to now go on their own, to go and do same. And at the end of the day, they won't be able to solve real life problems. So that cascades into them graduating and not being able to solve some of these problems. But however, some of our students who are lazy, we have to be frank. Some don't follow through assignments. If you give them projects, they don't do it. They ride on the project leader. Like you are teaching software design and architecture, for instance, you group them into groups. It's only some few, maybe 5 per group. It's only like 1 or 2 that will be active. Others will be riding on those leaders. At the end of the day, those leaders will have the knowledge, excel, and the others will just be as they are. So those are the problems that I noticed from my own experience. Thank you very much.
But I'm not going to allow you to sit down. I'm not going to sit down.
Okay.
Dr. Rufai, tell us your experience when you are coming to software.
Well,
when you had difficulties, what sort of difficulties did you have? And as a student, how did you solve it?
Okay. My background is mathematics. I got my first degree in mathematics. And we only did a little computing, like the elementary computing. But I now came to the University of Lagos and I did a postgraduate diploma in computer science. So that made me to now on my skills in programming. What I discovered is that you can't learn everything in the class. Like Dr. Akiburo said, don't say lecturer don't know how to code. They are doing research. I mean, lecturers' promotion are not based on, even if you are teaching and you are splitting fire like a dragon, nobody is going to, we don't have to promotion. So the system doesn't even recognize teaching. So when they come to, they are even doing you a favor by even coming to class. So the idea is they have other things they are doing aside from teaching and whatever. So the principal commitment of the lecturer is the research and the other activities. So that's it.
When you overcame your problem.
Okay, I overcame the problem. Yes. Okay, now I overcame it through.
You spend extra time.
Yes, you need to devote time. Luckily, during our time anyway, we depended on books, you know. The lecturers will come with the concept. They will teach you algorithm. They will teach you data structures. And when they teach you, they may use a pseudocode or this Pascal to demonstrate it. They are not expected to translate it to like Fortran. In those days, we used Fortran, you know, and some other language like Pascal, C, C++, Basic. Okay, we started with Basic, my own time. Basic, but COBOL, that is commercial oriented. That one is annoying because it has all manner of, yes. So we did that, but the programming is you need to, when you are given the concept by the lecturers or whoever has imparted on you, you have to really sit down and solve problems on your own. You develop apps. Although in our days, there was nothing like you are developing app with Fortran, but you write programs, you simulate and solve problems. And yes, before object-oriented programming came and others, yeah. And even as old as we also learn, you know, we now need to learn object orientation, the paradigm, all those paradigms, you need to learn it as well. Even lecturers, they sit down and learn. Okay, so that's it.
Thank you very much. Okay, let us, before we take you, because you have spoken once, no, Madam, just let us, we'll call you the next round. But let us see whether we can summarize and have takeaways, right? And I'm going to start. And if you feel that there anything you want to add as I'm starting, first of all, is it all lecturers that teach software programming that can actually program? Let us be honest. Let us say, oh, is it all lecturers that teach programming languages that can actually program? No, it's not. I'm not talking of supposed to. Can they actually program? No, please. I'm not playing politics. I'm being. I don't want to. I just want a yes or no answer. I don't want a political answer, Dr. Kiboro. Because I know, and I'll give you an answer. Is it all lecturers that teach programming languages? I'm trying to do summaries now. I'm trying to do takeaways.
All lecturers that teach programming language.
I expected.
But okay, I will use myself as a case study.
No, I want to answer that.
If you accept to teach a programming course,
yes,
you must be able to code.
Does it mean you can code?
You must be. You must be. If you give me a language that I don't understand, I won't take the course.
No,
I'll tell you I cannot code.
The way they give courses is that they say, Dr. Fashino, go and teach this course, and we go and teach it.
Must also be your area of strength too. Yes. If you're not strengthened in that area, you can't pass knowledge across.
Experience.
Yes, sir.
It is not all lecturers that teach programming language courses that can program.
And then
now, let me I will explain myself.
All right.
There are three aspects to programming. There are three aspects to programming. There's the program language aspect. While, this, before the programming language aspects,
yes, sir.
you must come to programming with three things.
Yes.
You must know Boolean algebra.
Algebra, yes.
You must understand functions, mathematics, functions, algebra, basic algebra. X plus Y is equal to Z. 3x plus Y is equal to Z. If X is equal to 2 and Y is equal to 3, then 3x plus Y is equal to 8. You must know basic algebra. If you want to come to programming, you must know Boolean algebra and you must know algebra. Those are two things you must know. Then what programming does for you is introduces it to the syntax of making Boolean algebra and algebra into an algorithm. And it comes to these structures like while, if, you know. So that's what programming does. So if you want to take a decision, you have to know Boolean algebra. If you want to implement a mathematical function, you must know Boolean algebra and basic algebra. So what programming does for you is to bring in control. If, else, when, why, then. So I tell my students, if you don't know Boolean algebra, you can't write programs. Now, as a lecturer, I can teach C language by reading Shum series C and teaching it in class. But does that mean I can write programs? You can only write programs if, with the knowledge of the syntax, you can take a problem and express it in the syntax. That is called algorithm building. When you want to write an algorithm, okay, if this is the problem, I can decompose this problem into this algorithm because I understand the structure of programming languages. Now, as a lecturer, I may not be able to do that. That's the fact. I take a problem. Okay, what's it called? What's this thing called? This small problem that we give. Tower of Hanoi. Yes. Solve the Tower of Hanoi. You look at it. It says this, it does this. Can you take that problem and decompose it into another? Can write it as an algorithm because you already understand the programming language. You already understand how algorithms are constructed. Can I take that problem and write it as an algorithm? That is the stage a lot of people fail, including lecturers. That's true. I'll give my own experience. I left Nigeria, I went to Imperial College. I got there, I'd not seen a computer before. I didn't know the difference between a programming language and an operating system. I was a complete novice. I didn't know anything about it. The only thing I knew was I bought a book on basic programming. Because I knew I was going to travel. I bought a book on basic programming, and I was reading basic programming. I'll read it, pencil. I bought it when I was in Ibadan, a year before I went to Imperial College. I'll just say, oh, this X is when I got there, and my mates came from, they were all of the graduates in engineering. I had a physics degree, and I went to do engineering. They knew how to program, they knew how to code. So when we are using CDC, this mainframe, this mainframe computers, and I would go to terminal and they were just coding. And I'll go there. I didn't know the difference between command line and Fortran itself. So it was very difficult for me. And that's why when students go through these phases, I know what they're passing through. It can be very complex and very confusing if you're a novice. If you enter the university, and that's going to take us second takeaway. The second takeaway is that to learn how to program takes time. Yeah. And somebody said, Dr. Kiboro said something. He said, in Bell University, they had lab technicians in the lab who would take the student through programming and database building, which the lecturers didn't have time to do. Somebody has to take you through it. Apart from the fact that you have to take the textbook and go through it line by line. Practice the examples and understand what they're doing. It's not an easy thing. And that's when I was talking the other day. I said, look, takes time. It's not something you can just, you want to teach C#. I think they come to class in one semester. I taught C# for almost 10 years. Come to class in one semester and they learn it in one semester and they can't. Because it's a different world. Programming is a different world entirely. It's both engineering and linguistics. Yeah. So it's not easy. So the thing is, we really have to look at the time is not just there. So some people have an advantage. They did some programming before they came to the university. They have that advantage. Then a lot of people don't. They think it's word, like you said. They think it's word processing and all that. That's not programming. As simple as programming is, before you can climb that hill. By the time I left Imperial College, I was already doing my project, right? And when I was coding, I didn't write my algorithms down. I didn't have to write my algorithms down. Just write it straight on the computer. And people are amazed that this guy just came in now. It took me time. It took me a long time. I had to sit down. In fact, it took a major part of my program. So when I left the program, then I now read the prospectus that you needed skills in C. So it takes a lot of time. So it's not something that, so if you want our students to be good in programming, if the lecturers teach it in class, then somebody must be in the lab, spending hours with them and putting them through. We all know that students don't want to read these days. So they have to put them through on a one-to-one basis. And if they can't do that, the students they can reduce that learning curve by what? By reading their textbooks and practicing and reading their textbooks. Let me tell you something. I teach my Java class, MIT. I use data when I'm teaching it. But I write the code. I tell them, okay, think of a problem. They tell me a problem. I will decompose it in class and I write the code. That's how I teach my Java to MIT students. I map the problem to the language. I say, this is the problem, and this is how the language will solve it. So as Dr. Edabami said, is one thing, how can you take the problem and express it in a programming language? But first of all, you must understand the programming language. And that's what Dr. Akibori was saying, that teachers can teach that. But can teachers teach how to program the stack of Hanoi? Can they do that? Can they take a very complex problem and decompose it into small little problems, then write those small little problems as code, then tie everything together to represent that big problem without it failing? It's an engineering task, although it's based on linguistic skills. So those are takeaways. So I still believe that if you want to have good programming language courses, they must be backed as software laboratories. And in those software laboratories, if the lecturers can volunteer to be there, which I think they won't want to, then the university must have people, competent hands who are skilled, technicians, who can actually take the students through. Because when you write code, the first thing that scares you is the errors. Yeah. When I was learning C++, my first code, when I wrote it, I saw 800 errors. I didn't look at that code again. I didn't touch it. I just let it go. I didn't touch it. Then I remember I spent weeks trying to solve memory leakage in C++. It's terrible. Weeks. Just the fact that you failed to put a destructor here, and that's why I migrated to C#. But then C# is not as efficient as C++. Yes. So all these things, they come with their trade-offs. Yes? What? So this thing you are saying that, oh, they started with C#, these things are still relevant. Even we are talking of NumPy. NumPy is one of the most powerful machine language packages you can ever have. It's written in C++. Then they wrap it around with they wrap Python on top of it and they hide all the complexity. So if you really want to do software engineering stuff, we have to do the C++. you want to build robust and stable systems, we still have to do the C++. So, any contributions?
Yes, sir. Yes, sir. Yeah. This is very interesting. One thing I like a lot, one subject I like a lot is programming. It's programming. I had my first degree in electrical. Now I want to talk about my journey to programming. I had my first degree in electrical. But back then at school, that was in the 90s. In the 90s, we were not exposed to, just as I said, all this programming. You are just Fortran, engineering programming Fortran that we are used to. Then it was even at my 200 level. So thereafter, nothing like programming. So when I got out, I wanted to start off something like computer firm. I've made up my mind that in year 3, look, I want to just start computer firm. I don't want to. And it was at that period, computer was coming to Africa. All this, that was the time where evolution of computer in Africa and all of that. So immediately I got out, I just set up a computer firm. I was reading textbooks on Cisco networking, Oracle, all by myself. So I had a lab in Italy where I go, I have computers there. I was teaching myself all of this networking and I'm managing companies, supporting. But I found out that something is lacking. Then I'll be following certification. Before you finish track, and I cannot be following track. I need to know the choice behind this thing so that whatever track that comes out, whatever certificate that, because this is not the theory, that will be my problem now because I will just go ahead and program whatever I want to do. So, and if I want to also support organization, I find out that my programming skill is not that high then because I don't know the theory. It affects my understanding in coding very well. So I now have to go back to computer science, pick up PGD. At that time, they don't allow, if you read electrical, they won't allow you to do master's straight. But I was ready to pay the sacrifice to pick up the theories behind the computer science and algorithms and data structures. So when I got to, I came back to academia, pick up course in, I pick up the firm in PGD, then I was already good in programming in C++. If your beginning is C++, I'm very sure you'll be sound in programming because every other programming, you just build on it, you just transfer the knowledge of C++ to it and you are good to go. So programming is not my program. Putting the codes together and systems together, 1 + 1, no, but the theories behind it, yeah, the working principles was lacking. So I came to computer science. I'm not after the coding, I'm after the theories that is behind what I do at the surface. How to link up the Boolean algebra as
There are 3 things: Boolean algebra, and data structure.
I was like, so I focus on those data structures, the theories of it, and of course, programming it is not my problem. Mathematics, I'm very good, like all of that. So I'm just after the computer science theories, so that whatever tracks that comes out, that won't be my problem because all of them they are built on the theoretical computer science as it is. So I can handle whatever it is and I can program. If it's not there, I'll code it. And that was how I pick up then I had a encounter with my guy. At that time, we were doing something together. I was on C++, said we should move to C#. I was I will now start learning C# again after I've invested so much in C++. So I'm going to go with C++. Anyway, I've done memory management, this model management. It is very difficult in C++. If you can manage your memory, at that time is good. So we started C#. Then I just go to C# and I just 2 weeks just plan to. You see, the syntax is similar. The only difference is the using and the libraries directories you put there and you are good to go. In fact, I find it very easy. All those Windows things, I get no problem. You see, before so I moved to C sharp, C sharp. In fact, I now came and relaxed with C sharp because I have developed business applications, support companies, and on C sharp platform. So, but later, as I look into other programming language, I found out that look, the only investment you need is that first investment in a very good programming language. It will take you time. If you need education, you overnight, in fact, hours, you are still coding, you need that pain. You need the pain to get stabilized, to get so that you can fly. Maybe you get it right at that first programming language. That's all you need. You just transfer that knowledge. You just look at all this one there. You'll be able to read the lines straight. As you see it, you just read the lines straight. As you see it, you just read the lines straight. There won't be any problem with that. There won't be a problem with that. So that first sacrifice will take time and pain, but you just need to sit down, get it through. Maybe you get it through, other ones, it's like a peanut. In 2 weeks, 2 weeks is even too much. So I now went to, when I want to do my scientific program, at that time, C# have not put so much scientific data matrix multiplication into C# then. I moved to MATLAB. Very simple, because of previous experience. In fact, I'm at home with MATLAB. And when it comes to scientific programming, I go for MATLAB. When it comes to business programming, I want to do business, I go for C#. Any language that you want to use, depending on the problem at hand. And that's what I just invoke that language and I use that. That's my small.
So I think we should round up now. Yes. So I want to answer a question that you said, oh, what are we supposed to learn? I think we should learn a structured programming language. Object-oriented. Object-oriented structure, object-oriented programming language that is strongly typed. Yes. Strongly typed object-oriented programming language. Once you learn that, C++, C#, Java, they are strongly typed. But if you learn, that's the safest. Personally, that's my recommendation. Then after that, I can go and learn Python, all this nonsense, React, and the rest of them. So that is my own advice. So let us round up, and we'll now, if you want, you just in 1 or 2 sentences, I want us to have you to advise, or as a young person, what you have picked up. Just 1 or 2 sentences. Or if you are in faculty, advise young people on where to go on software engineering, because software engineering now is a different ballgame together. Programming is something, software engineering is different thing. Software engineering is you have to pick up an engineering skill set, and that's why with the creation of object-oriented language, it was possible to create software engineering, because object-oriented was created to make it look like to make programming look like engineering. Yeah. Objects were created to make it look like engineering, right? So with object-oriented programming, the next thing that came up, I'm very lucky. I learned software engineering when I was in England. That was when it came out. I learned in 1984. It was about 2 years when this thing came out. So, and I've been teaching this ever since and all that. So software engineering is about bringing engineering skills and building large systems, not just small things, complex systems. So that's the whole idea. But if you don't know your basic Boolean algebra, basic algebra, and data structures, you're in trouble. So please, if you're faculty and you have any advice, 1 or 2 sentences. If you're a student, a sentence of what you have gained. So please, let's just round up. Yes, a sentence, please.
Okay. Mine is we need to also involve the industry practitioners and see their perspective. So, okay. So industry, what do you expect from students?
Thank you very much. So in computer science, it is expected that graduates of computer science, they hit the ground and run from day one. not that they will come into the industry and we'll start teaching them. So, and for now, it has been established that most people that graduate from computer science don't really acquire that skill of programming from the school. And I'm happy to be part of the conversation today. I've seen some of the things that are being done to make that really work. Yes. So.
Thank you very much.
Exactly.
Just one sentence of advice. You heard what the industry person said.
Yeah, I heard her clearly, but well, yes, I think that is one of the problems we're having. When you expect a student to just be employed in an industry and hit the ground running, that's what's supposed to be. But there should be also always be industry that are employing students and taking them for training for like 1 month, 2 months to let them know the requirement of the company and what is expected. I think that they know what knowledge they want to pass across. But I won't want to go to that. But my own is just my own contribution towards the question you asked. Well, I want to advise students to believe in themselves, believe that you can do it, and that's the spirit that is keeping me going. And that spirit, I learned it during my undergraduate when Professor Mindora gave me a problem to solve. And for good 5-6 months, I was just blank. Then, no, there wasn't information like this then. But I just look at myself, I said, but what is it that is in this problem that I cannot even solve? And I locked myself up for 2 weeks. And by the time I came out, within that 2 weeks, I came out with the result. And I went to go and present something to the man. The man has already scored me low. He changed immediately in my presence. He gave me hey. That was when, since that year, I've fought. When I was doing, he helped me when I was doing my master's. Professor Dave supervised the master's. In fact, the first time I gave, because of that spirit, the first time I gave him my proposal, he asked me to go and apply for seminar immediately, just because I believe I can do it. So let's have the spirit that you can do it. No problem that cannot be solved. You can. It's the spirit. No, sir, if you don't believe in yourself, if you don't, no, sir, I know where I'm coming from. You see, when you see a problem and you see it's too big that you now felt you can't do it at all, it becomes a mountain to you. If you have the belief that this thing, no matter how big it is, you can do it, you'll be able to sit down, take time for it, and do it. So that is the spirit.
I also have an advice to students and to everybody. And I want to tell us that we should not jump before our time. A lot of time, the problem we live is what we'll face later on. And most of all these things, that's what he said, they are prerequisites. If you are meant to have known your maybe linear algebra very well, and you want to have a shortcut to it, and you are looking at becoming a programmer later on, you still come back to that problem. So you must understand, you must go extra effort, very deep, and don't rush before time. Just take things easy, learn very well, and you move forward. Thank you.
Thank you very much.
Okay, so my own advice is based on my own experience. Is you should learn how to prioritize your activities, what you want to do, and learn to put. Let's say if others are giving 70 hours, you should give like 100 hours to the work to get extra results to achieve excellence. And that was what I think. Thank you.
Thank you very much.
My own suggestion is we students, especially those coming into our institutions, should try to put in a little time to do proper research about what they are going into before they actually endeavor into going into it. Yes, about not just Microsoft. Then also, I think the school should also give more time to the learning period by trying to alleviate the unnecessary things that we inculcate into the curriculum. For example, when I got into computer science, the 100 level, I had to do biology, chemistry, and all those things. Meanwhile, I already dropped biology things like SS1 or so. So those things are not so relevant to the degree I'm coming in to get. And I don't even have enough time to learn the actual computer science I'm coming in to do. So, yeah, exactly.
Yes, hello, Can I have another? Exactly. You need it. Can I have that?
So my takeaway is what he said is that we should learn a particular programming language very well, like be good at something very well first before we say to.
Thank you very much. So
a round of applause for this session for Dr. Fashino. Thank you, sir. Dr. Fashino happens to be my PhD supervisor. Round of applause. Okay, so our time is far spent. So at this point, I would like to call on our distinguished facilitator, Professor Bridget Fassenstrider, to give us the wrap-up and reflections.
Well, that was a very interesting discussion. Very interesting to observe from the back corner here. It got pretty heated in the discussion. This will be a very short reflection and wrap up because we have a whole week ahead of us. And what I would take away from today is we've given you more tools than one can easily digest within a day and more references one can read within a couple of weeks in the keynote talk, presenting the work that we have done over the past decade in a very abbreviated version. And then we've put all of you to work to think about, well, what does it really mean to teach sustainability within a software engineering context when we look very specifically at the African perspective, and how could we match teaching practices, map teaching practices from there? And we've collected a ton of input from you, and we'll also make that available because there were some really good thoughts in there, both in your verbal summaries as well as in what you had posted on Slido. And then in this third session, we heard a lot about things that are already going well and are pretty exciting here in teaching software engineering in Nigeria, and things that can still be improved. And that's what we're going to spend the rest of the week on, like what can we improve in software engineering education when it comes to integrating sustainability. And maybe on the way, we can solve a couple of the challenges that you mentioned today in the session. So would you like to add anything, Colin or Shola?
I think it's really nice to see that one of the key focuses on programming language. So, which will a bit shape how this week goes. Maybe part of integrating sustainability into the curriculum, we can also look at programming language as a case study, because maybe that is something you can also relate to in addition to what we've originally planned. So thanks for sharing some of those challenges. And also maybe on Wednesday or Thursday, no, I think it's Wednesday, we can also share from our European perspective how this has been done. And I think tomorrow, Colin might add few on the Limerick model, talking about some of the challenges you've highlighted on why do we have very few % of graduates with good programming skill. And I think Limerick has a good model for that.
Thank you. Colin, any additions?
So thanks for being engaging attendees today. It's really interesting to hear your perspectives on this. And for me, I think the real takeaway today is that you really understand the problems that you face. And so the question becomes, how can we help you resolve those? What can you take away from some of the things that we do that might be interesting to help you resolve those in particular contexts? So that's, the thing that I would like to sort of leave you with today, is that you have a great understanding of your own problems and challenges. And there are some things that you could potentially take away from some of the things that are done in different places. Not necessarily adopt them, but shape them around the problems that you have. You know, I think someone made the observation that we often mimic what is done in other places, and it doesn't work. You know, I mean, Africa is littered with Western solutions to African problems, which is, of course, the classic computer science thing, isn't it? Here's the answer, but I have no idea what the question is. But this must be the answer to all your problems. So I think you already understand what the questions are. And I think if we can integrate some of these together over the course of the week, I'd be very interested to see what the outcome is. So thank you for your participation.
And with that, as a little preview for tomorrow, tomorrow we'll continue with a lot of interactivity. So we're gonna work in little groups again. We want to work on courses that you would like to integrate sustainability more into. And we're gonna use the guideline that I presented today within the keynote to look at a couple of suggestions of how that can be done. And then we'll look at whether that actually works for your courses, because maybe your courses are structured differently and we need new ideas and better ways of how to do that. So be prepared for tomorrow. It's going to be interactive again. There's not a whole lot of input. We've done most of the input. From here, we get to work together and collaborate and make new things. So thank you so much.
Thank you very much. On this note, let's give a super round of applause for all our participants.
Thank you very much. So at this point, we are closing, and please, let's make it 9 sharp tomorrow. Well, yes, and those online, we are also very grateful for your engaging participation. Especially, we even got so many questions from the online people. Thank you very much. Applause for you over there. Thank you. So we're expecting you to join us tomorrow. This time around, we are starting 9 on the dot. So we've taken care of all the little logistics, and we're sorry for starting some minutes behind the schedule. So thank you very much. All the best. So good day, everyone.